When was the last time NASA went quiet? When has the James Webb Space Telescope, usually so quick to show us breathtaking new images, suddenly fallen silent for weeks? Or Hubble, after capturing something extraordinary, simply stopped speaking about it? That's the unsettling reality now surrounding 3I Atlas, our third interstellar visitor. Discovered in July, it arrived with a glow that raised more questions than it answered. A massive halo of carbon dioxide, a strange green shimmer, a tail pointing the wrong way. At first, updates trickled in then. In August, the silence began. Webb's spectroscopy slipped into limbo. Hubble's reports grew sparse. What we received instead were generic notes, sanitized statements, and a sense that something was being held back. And all the while, Atlas drifts closer to Mars, to the sun, to its fleeting moment in our skies. If this were any other comet, the stream of images would be endless. But here, we're left with quiet corridors, unanswered questions, and the uneasy thought, what have they seen that they aren't ready to share? Tonight, we'll drift into that silence. We'll follow the path of Atlas across the heavens, compare it with the visitors before, and explore the theories born from what's missing as much as from what's known. And welcome back to the Sleepy Explorer, a quiet vessel where the cosmos becomes a bedtime story and wonder moves at the pace of a lullaby. Before we set off, I'd love to know, where are you listening from tonight? Is it late with the lamp dim and the room hushed? Share your local time if you'd like. It's always magical to see how our sleepy constellation of listeners stretches across the earth. And if this slow journey brings you even a breath of calm, you're welcome to like the video or subscribe only if it feels right. That way, this little ship of starlight can keep drifting, carrying new travelers into the night. So let's begin tonight's story. 3I Atlas and the secrets NASA doesn't want us to know. In the modern age of astronomy, silence is unusual. Each time the James Webb Space Telescope peers into the deep, NASA usually celebrates with dazzling portraits, the nebulae in vibrant colour, galaxies etched like jewellery against black velvet. Hubble, too, for more than 3 decades, has been a reliable storyteller, showing us snapshots of comets, planets, and the occasional surprise visitor. Yet, with 3I Atlas, their voices have dimmed. Discovered on the 1st of July, this interstellar wanderer captured immediate attention. At first, images appeared quickly. A bright coma, larger than expected, surrounded its nucleus. Observers noted a strange greenish hue, likely from carbon compounds glowing in sunlight, but odd enough to spark whispers of something stranger. Amateur astronomers shared their excitement, stacking exposures through backyard telescopes, posting streaks of light on forums, offering raw but honest glimpses. It felt like a cosmic event in motion. Then, almost without explanation, the stream slowed. By August, when Atlas had crept closer to the inner planets, the official channels grew quiet. Hubble's updates, once regular, became rare. Webb spectroscopy promised to unravel the chemistry of this foreign visitor seemed to vanish into a holding pattern. Press releases offered little more than technical phrases, softened into near silence. For those who remembered the daily flood of images during comets like Neowise, the contrast was unsettling. To the casual observer, this might have passed unnoticed. After all, the night sky is busy, and new stories arrive each week. But for those who had been following closely, those who wanted to know whether this green-tailed traveller held clues to life beyond our solar system, the sudden quiet rang louder than any headline. Silence, when you expect wonder, feels like a missing heartbeat. And so the questions began. Why now? Why would the telescopes that gave us galaxies 1 billion light-years away hesitate to share pictures of a comet only millions of miles from home? Were the instruments busy elsewhere? Was the timing unlucky, the sun's glare making observations difficult? Or was there something captured in those raw files that demanded caution before release? Theories bloomed as quickly as the coma itself. Some said NASA was being careful, ensuring accuracy before stirring public excitement. Others wondered if the data showed anomalies features too odd, too easily misread as artificial, and therefore withheld to avoid speculation. In truth, both possibilities could be true at once. Science is patient, but the public imagination is not. In the vacuum between the two, stories grow. For now, what we can say is this: 3i Atlas is still out there, drifting with its green veil and tilted tail. But the images that should have painted its portrait remain strangely sparse, as if someone has lowered the volume on a symphony we long to hear in full. To understand why this hush feels so unusual, it helps to look at the rhythm of astronomy in the past. When comet Neowise lit up the sky in 2020, images poured in daily Hubble's crisp snapshots, wide-field photographs from ground observatories, even breathtaking composites meant for social media. The same happened with asteroid Bennu. Every new frame from OSIRIS-REx was released with almost theatrical timing, keeping the public enthralled. These updates weren't just science, they were part of the performance, a cosmic spectacle shared openly with the world. Now, with 3i Atlas, the stage lights seem dimmed. What we see instead are fragments, amateur photographs stitched from backyard observatories, a handful of official data releases, shrouded in technical language, and then long stretches of nothing. For a traveller carrying the weight of being only the third confirmed interstellar object in human history, the silence feels disproportionate. This is not just any comet, it is a messenger from beyond our solar system, here for a fleeting visit before disappearing forever. Astronomers outside the agencies continue to watch. They report a coma of astonishing size, hundreds of thousands of kilometers across, almost dwarfing the Earth itself in scale. They notice the peculiar orientation of its anti-tail, pointing back toward the sun rather than away. They note a color shift, the green tinge deepening, possibly from carbon dioxide and cyanogen gases fluorescing under sunlight. Each of these features should have been the spark for official excitement. And yet, from the institutions most capable of explaining them, little more than cautious footnotes emerge. In online forums and small astronomy circles, speculation runs unchecked. Some suggest the simplest reason: telescope schedules are crowded, and not every object can remain in the spotlight. Others argue that the geometry of Atlas's orbit places it close to the sun's glare, making observations difficult in August and September. Both explanations make sense, but alongside them, more dramatic ideas take hold that perhaps what Webb or Hubble captured did not match expectations, or worse, hinted at structures too easily mistaken for something engineered. In an era of viral headlines and social media storms, withholding becomes the safer option. Yet here is the paradox. Silence breeds more speculation than clarity ever could. By not speaking, by not showing, the agencies have allowed 3i Atlas to become less a comet and more a canvas. Upon that canvas, people paint their fears, their hopes, their conspiracies. The missing images are no longer just data, they have become symbols of mistrust. And so, as Atlas edges closer to its near pass by Mars, the hush around it deepens. We are left with more questions than pictures, and the eerie sense that a story is unfolding just out of sight. The missing images matter not just because we crave beauty, but because they are the foundation of trust. When Hubble's mirrors open, or Webb's gold hexagons tilt toward the void, the public assumes a pact, that what is seen will eventually be shared. It may take time processing raw pixels into calibrated data, stripping away cosmic rays and noise, but the rhythm of disclosure has long been steady. With 3i Atlas, that rhythm falters. This faltering is amplified by the object's uniqueness. Unlike routine comets that swing by every few decades, this visitor will never return. Its trajectory is hyperbolic, carrying it out of the solar system after this one brief encounter. We do not have the luxury of waiting centuries for another pass. Every image withheld feels like a page torn from a book that can never be reprinted. Consider, too, the human element. In a world where space agencies compete for attention, spectacular imagery often serves as both science and spectacle. To suddenly withhold that, spectacle sends a signal more powerful than words. Silence becomes a story in itself. It suggests caution, or conflict, or simply priorities unknown to us. And in that gap, imagination takes the stage. Perhaps the truth is mundane, perhaps the raw data are messy, or calibration is still underway. Perhaps the angle between Atlas and the Sun makes clean imaging difficult, and scientists are reluctant to release imperfect pictures. These are reasonable explanations, and very likely the right ones. But reason has little influence in the echo chamber of uncertainty. Where clarity is absent, conjecture grows tall. As we close this first chapter, what we hold is not just curiosity about 3I Atlas, but a mirror reflecting our hunger for transparency. A comet's coma may glow green with molecules we can name, but the silence around it glows with something harder to measure: our restless imagination. And this is where the story must turn toward the facts we do have, the things already learned about this wanderer from beyond. For only by grounding ourselves in what is known can we begin to measure the weight of what is missing. Silence, then, is never truly empty. It is filled with echoes of what we expect to hear and the weight of what never arrives. The missing images of 3I Atlas remind us not only of our hunger for clarity, but also of how quickly absence becomes its own kind of presence. A hush in the cosmos can stir louder questions than any press release. And so the story turns. If the silence leaves us uneasy, perhaps the best way forward is to gather what we already know, to hold in our hands the few solid pieces of this puzzle. For only by tracing those known facts can we see more clearly where the shadows still linger. In the next section, we'll do just that, laying out what astronomers have confirmed about 3I Atlas so far, and how those details already set it apart from the visitors that came before. Before we drift too far into speculation, it helps to pause and anchor ourselves in what astronomers have actually seen. 3I Atlas, for all the mystery that surrounds it, is not a phantom. It has coordinates, a trajectory, and a dossier of early observations that sketch its outline against the void. The first recorded sighting came on the night of the 1st of July 2025. Automated sky surveys caught a faint, moving speck among the background stars. Within hours, its track betrayed something unusual, a path not bound to the sun, but sweeping inward on a hyperbolic orbit. That meant only one thing: this was no ordinary comet wandering the long loops of the Oort cloud. It was an interstellar traveller, born elsewhere, destined never to return. Astronomers designated it 3I Atlas, the third interstellar object after ʻOumuamua in 2017 and Borisov in 2019. Already it had a place in history. Early estimates placed its nucleus at only a few kilometres across, comparable in size to many comets we have studied before. But around that small core stretched a coma of astonishing scale, hundreds of thousands of kilometres wide, a cloud so vast that Earth itself could fit inside. Observations with Hubble and ground-based telescopes suggested this coma was dominated by carbon dioxide, with fainter signatures of water vapour and other gases. That detail alone made Atlas unusual. Most comets are driven primarily by water ice, sublimating in sunlight, not by carbon dioxide on such a scale. The colour was another surprise. Amateur images showed a greenish tint, as though the object were lit from within by some alien chemistry. In truth, this glow was most likely from diatomic carbon C, two molecules fluorescing under ultraviolet light, a familiar phenomenon in cometary science. Still, the intensity of the hue captured imaginations. It was easy to imagine a shard from another star, wrapped in a veil of light foreign to our own skies. The orbit carried Atlas inward, threading between Mars and the Sunday. Its closest approach to Mars would occur on October 3, though close as relative tens of millions of kilometres still stretched between them. Later, on October 2930, it would pass perihelion, skimming near the Sun at a distance closer than Earth's orbit. After that, it would fade into the black, outbound on a path no spacecraft could follow. For now, though, it remains visible. Night after night, telescopes large and small trace its position, watching how its coma expands, how its brightness shifts. Already, astronomers note that it is brightening faster than expected, as though some hidden reservoir of volatile material is being tapped. Whether this foretells a dramatic outburst or simply a gradual blooming, no one can yet say. And so, in the midst of silence, these are the facts we can hold. A small nucleus, a vast carbon dioxide coma, a green glow, a hyperbolic trajectory. They are enough to confirm its otherworldly origin, enough to make it unlike any comet we've catalogued before. But they are also fragments, each raising as many questions as they answer. To see how remarkable these fragments are, it helps to place them alongside what we know of other interstellar visitors. When Oumuamua first arrived, its strangeness was wrapped in simplicity. No coma, no tail, just a tumbling shard with odd acceleration. Borisov, by contrast, was unmistakably comet-like, its behaviour almost textbook. But 3I Atlas sits somewhere in between neither a naked fragment nor a conventional comet, but a hybrid that complicates every neat category. Consider its coma. Ground-based observatories in Chile and Hawaii reported dimensions approaching 300,000 kilometres, with some estimates stretching beyond that, an envelope of gas and dust so inflated that its edge was difficult to define. To put it in perspective, this makes the visible atmosphere of Atlas several times larger than Jupiter, and yet its nucleus, the solid heart at the centre, may be only a few kilometres wide. The contrast is absurd, like a grain of sand shrouded by a balloon the size of a continent. This is not unheard of for comets, but the dominance of carbon dioxide in sustaining such a vast halo is unusual, even disquieting. Then there is the anti-tail, a stream of dust pointing not away from the Sun but toward it. This counterintuitive geometry arises from orbital perspective. Tiny grains left behind along the comet's path appear, from Earth's vantage point, to angle back toward the Sunday. Still, in popular imagination, the effect is eerie. A comet with a tail defying the Sun's wind seems to violate an ancient script. For 3I Atlas, the anti-tail is not merely a quirk of optics, but a symbol of inversion, a reminder that this object comes from beyond our rules. Brightness is another puzzle. Most comets brighten in predictable steps as they approach the Sun, their ices vaporizing steadily. Atlas, however, surged ahead of schedule, glowing more intensely than models projected. Some amateur observers reported that its magnitude increased almost twice as quickly as expected during August and September. If true, this suggests reservoirs of volatile material carbon dioxide, carbon monoxide, even obscure ices like OCS were buried close to the surface, ready to erupt with only modest heating. For astronomers, such behaviour is a goldmine, a chance to learn how comets form under conditions utterly different from our own solar nursery. The timeline of its journey adds urgency. On October 3, the comet will sweep nearest to Mars, a tantalizing chance for spacecraft in Martian orbit, like ESA's Mars Express or NASA's Mars Reconnaissance Orbiter, to take images from a perspective unavailable to Earth. Then, at perihelion on October 2930, Atlas will endure its closest brush with the Sunday. What happens there is anyone's guess. It may brighten spectacularly, fragment under thermal stress, or vanish into a fainter wisp than expected. Each possibility is a story in itself. Despite the sparse official releases, one truth is undeniable. We are witnessing something rare. Interstellar objects are not just uncommon, they are once-in-a-lifetime events. The solar system has been visited by only 3 confirmed wanderers in recorded history, and Atlas is by far the most chemically dramatic. Every observation, every data point, is a message carried across untold light years, whispered into our instruments for only a fleeting season. This is the weight of what we know. A green-tinged coma swollen by carbon dioxide, an anti-tail that bends the imagination, a brightness racing ahead of predictions, and an orbit that will carry it forever away once its brief dance near the sun is done. These are not rumours. These are not theories. They are facts, and they are enough to remind us that the universe still holds surprises we have not prepared for. To hold all of this in view is to sense the delicate balance between certainty and wonder. Three-Eye Atlas is not a rumour, whispered in the dark. It is a physical traveller. Its coordinates plotted, its orbit traced, its spectrum recorded. Yet each fact carries within it the seed of further mystery. Take its chemistry. Webb's early spectra, though not widely publicised, hinted at a cocktail of gases: carbon dioxide in abundance, faint signatures of water, carbon monoxide, and exotic traces like OCS and crystalline water ice. These findings suggest that Atlas formed in a region of its home system, colder and more volatile rich than the environments where most of our comets were born. That, in itself, is astonishing. It means the comet is a direct sample of alien conditions, a fragment of planetary science written in a different dialect. Or consider its trajectory. Hyperbolic, yes, but with an inclination and velocity that feel almost convenient from our vantage point. It passes within observational reach of both Earth and Mars, threading a corridor that allows multiple spacecraft to catch glimpses. Statistically, this is not impossible. Interstellar debris can arrive from any direction, but still, astronomers admit it is unusual. Cosmic chance often feels uncanny when it aligns so neatly with opportunity. And then there is the timing. Only 8 years separate Atlas from ʻOumuamua and just 6 from Borisov. Before that, no confirmed interstellar visitors had ever been seen. Have we suddenly entered a busier corridor of the galaxy? Or have our instruments simply become sharp enough to notice wanderers that always passed unseen? The data lean toward the latter, yet the clustering of these arrivals invites a more poetic suspicion that the cosmos has seasons, and that we are living in one of its stormier moments. For the public, these facts can blur into speculation. A coma measured in planetary scales, a tail pointing the wrong way, a glow of alien chemistry. It all sounds like the language of science fiction. But within observatories, these are data points, real and measured, waiting to be explained by models. The gulf between those two perspectives, the dreamer's awe and the scientist's patience, is the fertile ground where stories grow. So far, this is what we can say with confidence. Three-Eye Atlas is an interstellar comet born beyond our solar system. Its coma is vast, its chemistry strange, its orbit unbound. It is real, measurable, and fleeting, and even if no more images are released, these truths remain. And so, with Three-Eye Atlas sketched in light and chemistry, we now face a subtler question. For knowledge alone does not still the unease. It is the silence surrounding those facts that shapes how we imagine them. And in the next section, we ask why that silence matters. Silence is never just the absence of sound. It is a presence in its own right, shaping what we feel and how we interpret the world around us. In astronomy, silence carries a peculiar weight. We live in an era when every discovery is amplified, every image broadcast within hours, every new dataset turned into press releases and headlines. Against that backdrop, the quiet surrounding Three-Eye Atlas does not feel natural. It feels pointed, and that is why it matters. When Hubble, or the James Webb Space Telescope, observes a distant galaxy, the results are usually shared within days. Nebulae, star clusters, even exoplanet atmospheres, images and spectra flow into the public sphere with almost theatrical consistency. Space agencies have learned that part of their mission is not only to do science, but also to show it, to remind us that the cosmos belongs to everyone. Silence in this culture of spectacle is jarring. It breaks the pattern. It makes us wonder, what happened? The answer may be innocent. The process of turning raw telescope data into publishable images is long and careful. Scientists strip away noise, calibrate instruments, and check for errors. A single misinterpretation could mislead not only the public, but also the scientific community itself. There is wisdom in caution, but caution is easily misread when paired with a hush. In the space between data and disclosure, doubt grows. We have seen this before. When images of Pluto from New Horizons trickled out in 2015, even the smallest gaps in communication created waves of speculation. People imagined cities on the surface, alien bases hidden beneath icy plains. None of it was real, but silence gave those ideas room to breathe. Something similar is happening now. With 3i Atlas, the absence of new images has become louder than the comet itself. The risk is not just curiosity turning into wild theories. It is trust itself beginning to erode. For decades, the relationship between science and the public has been a fragile compact. You show us what you see, and we believe you when you explain it. That compact is strongest when images flow freely, when discoveries are made visible, break the flow, and the compact begins to fray. Even the most reasonable explanations, instrument schedules, data backlogs, unfavorable geometry, cannot fully silence the suspicion that something is being withheld. And so the importance of this moment is not only about 3i Atlas, it is about the bond between those who watch the skies and those who wait to be shown what the skies reveal. Silence places that bond under strain. It raises questions larger than any single comet, about transparency, about authority, about whether the stars are shared freely or filtered carefully. To understand why this silence resonates so strongly, we need to consider how accustomed we have become to immediacy. The digital age has trained us to expect real-time updates, live-streamed rocket launches, social media threads from planetary probes, instant comparisons of before and after images. Astronomy, once the slow craft of patient skywatching, now unfolds like a rolling news cycle. And when that cycle suddenly falters, people notice. For many, the silence around 3i Atlas feels like a broken promise. Here is a visitor from beyond the stars, one of only 3 such objects ever confirmed, and yet the flow of images and explanations has slowed to a trickle. It is not simply a matter of curiosity left unsatisfied. It is a matter of trust disrupted. If agencies will eagerly share images of distant galaxies and common comets, why do they hesitate with this one? That discrepancy becomes the soil in which suspicion grows. Skepticism, once planted, spreads quickly. Online discussions multiply theories ranging from the plausible technical delays, unfavorable geometry, overwhelmed research teams, to the fantastical, that Atlas shows signs of being engineered, or that its chemistry contains something disruptive. Most scientists would shake their heads at these leaps, but the point is not whether they are true. The point is that they thrive in the vacuum left by official silence. This is how absence reshapes perception. What is not said often speaks louder than what is. Each day without an image becomes, in the public mind, evidence of concealment. Each vague update reads like deliberate evasion. The comet itself is transformed, not by what it is, but by how it is framed or left unframed by those with the authority to show it. And here lies the subtle danger. A gap in communication may seem minor within the scientific process, where months of calibration and peer review are ordinary, but outside that process, in the quick-turning world of public attention, silence is combustible. It can erode the credibility of institutions painstakingly built over decades. It can turn a scientific puzzle into a cultural flashpoint. For 3i Atlas, then, the silence matters because it shapes not only how we see this comet, but how we see science itself. In the hush, wonder is still alive, but it is joined by doubt and by the uneasy sense that perhaps we are not being told the whole story. Silence is a mirror, and in its surface we glimpse not just the comet, but ourselves. The quiet around 3I Atlas has revealed how deeply we rely on images to anchor belief. Without them, we find it hard to hold certainty in our hands. Numbers and coordinates may satisfy scientists, but for the rest of us, a picture feels like proof. When the picture is absent, proof feels incomplete. This absence has consequences. For some, it is a spark of creativity filling the gap with theories and stories. For others, it is a seed of suspicion, gnawing at their faith in the institutions meant to guide us. And for still others, it is simply frustration, the sense of being left outside the circle of knowledge at the very moment when curiosity is highest. Silence, in other words, does not remain neutral. It bends thought, reshapes trust, and alters the story we tell ourselves about the universe. Perhaps this is inevitable. The more spectacular the discovery, the heavier the weight of expectation. ʻOumuamua and Borisov were followed almost obsessively by the public, each new detail sparking debate and fascination. 3I Atlas, with its luminous green veil and enormous coma, seemed destined for the same treatment. Yet its narrative has stumbled not because the comet is less strange, but because the silence has slowed its story. In that slowing, a simple scientific process has taken on the shadow of secrecy. This is why the silence matters. It is not just about astronomy. It is about the fragile relationship between knowledge and trust. For when trust falters, even the brightest comet cannot fully shine in our eyes. The glow becomes coloured by suspicion, and the wonder becomes tangled with unease. And so, having seen how silence reshapes the way we listen to the cosmos, we turn next to the theories that try to explain it. For every hush invites speculation, and the gaps around 3I Atlas have been filled with possibilities, both sober and strange. Every silence invites explanation. The human mind resists a vacuum. Where no answer is given, we create one. And in the case of 3I Atlas, explanations have multiplied. Some are sober, grounded in the realities of telescope schedules and data pipelines. Others wander further into the speculative territory where astronomy brushes against conspiracy. Each theory reflects less about the comet itself than about the way we grapple with uncertainty. The first cluster of theories is the most practical. Processing space telescope data is a meticulous, slow craft. Raw images from Hubble or spectra from Webb are not immediately ready for the public eye. Cosmic rays must be subtracted, distortions corrected, calibrations checked against known standards. A single misstep could mislead the scientific record. In this view, the delay is not sinister but careful. Astronomers are simply taking the time to get it right, even if that patience looks like secrecy from the outside. Another explanation points to the tyranny of scheduling. Hubble and Webb are in high demand, with observation time rationed months in advance. A comet, even one interstellar, must compete with distant galaxies, exoplanet atmospheres, and countless other projects. It may be that Atlas has received only a handful of observation windows, scattered and insufficient to create a continuous stream of updates. If so, the silence is a matter of logistics rather than intent. Then there is the geometry of the sky itself. By late August and September, 3I Atlas edged closer to the sun's glare. Observing such an object becomes difficult, even dangerous for instruments not designed to peer near the solar disk. For ground-based telescopes, the horizon can swallow it before enough exposures are captured. For space telescopes, pointing restrictions may forbid risking delicate optics. The silence, in this sense, may be forced upon us by physics, not people. But explanations grounded in patience, scheduling, and geometry satisfy only some. For others, the hush feels heavier. Why, they ask, would agencies so eager to share distant galaxies hesitate with a comet practically on our doorstep? Why allow amateur astronomers to shape the narrative with their grainy backyard images while the most powerful observatories on Earth and in orbit stay muted? Here, the more speculative theories begin. Some imagine that the data contain anomalies, strange features that, released without careful framing, might be misinterpreted as evidence of alien technology. Others suggest that certain spectra could hint at unfamiliar chemistry, compounds difficult to explain within our models, better to be studied quietly before being made public. In both cases, the silence is not seen as caution but as concealment, a barrier between the truth and the people who demand it. In truth, no single explanation is likely to tell the whole story. A comet like 3I Atlas challenges our categories, our timelines, and our expectations. The silence around it is probably stitched together from all of these threads: practical constraints, technical caution, and a desire to avoid sparking misinterpretation. But stitched together or not, it becomes its own fabric, one the public must read without guidance. And that, more than any chemical spectrum or orbital detail, is why theories thrive. Silence is never blank. It is a canvas, and on it we paint our doubts, our hopes, and our fears. Among the more grounded explanations, there is also the possibility of simple human caution. Agencies like NASA and ESA operate under intense scrutiny. A single misstatement can fuel headlines for years, especially when it involves the faintest suggestion of life or technology beyond Earth. With 3I Atlas, whose chemistry and appearance already lean toward the unusual, the risk of miscommunication is especially high. Better, perhaps, to say nothing until the analysis is airtight. Yet in saying nothing, they may have stumbled into the very problem they sought to avoid, fueling speculation by omission. For others, the hush looks less like scientific prudence and more like strategy. They point to patterns in the way governments and scientific institutions have handled uncomfortable discoveries before. When the Pentagon released its UAP reports, for instance, many observers noted how carefully worded the documents were, acknowledging anomalies, but never offering concrete explanations. Could the same logic be at work here? By controlling the flow of information, by limiting the release of images, perhaps the agencies hope to steer interpretation, keeping the narrative in manageable bounds. Still others view the timing with suspicion. As 3I Atlas crept closer to Mars in September, attention in the media seemed to drift elsewhere, toward other comets, toward unrelated astronomical curiosities. Some saw this as misdirection, a deliberate choice to shift the spotlight. It may simply have been coincidence, the natural ebb and flow of coverage. But to a public already primed by silence, coincidence can look like choreography. The range of theories expands further, the longer the silence persists. Some are extravagant whispers that the comet is not a comet at all but a vessel, or debris from an engineered structure, or the fragment of some unknown technology. Few scientists would entertain such claims, but in the absence of steady updates, they spread across forums and social media, feeding on the mystery. It is tempting to dismiss these speculations outright, yet to do so misses the deeper point. The theories matter not because they are true, but because they reveal how people respond when trust is strained. In every rumor, there is the echo of a question left unanswered. Why are the images scarce? Why is the data delayed? Why does the silence feel so deliberate? Theories, then, are the mind's way of filling the void. They are not proof, but projections, shadows cast by a comet's glow, shaped more by human imagination than by the object itself. The real danger is not that these theories exist, but that they flourish in the cracks where communication falters. What emerges from this web of speculation is less a portrait of 3I Atlas than of ourselves. In the hush, every possibility finds room, the practical, the paranoid, the poetic. Each theory is a reflection of our hunger for answers, and our discomfort when those answers arrive too slowly. In a sense, the comet has become a canvas for projection. We see in its glow not only chemistry, but also the shape of our own doubts. Perhaps the truth is far simpler than any of these stories suggest. Perhaps the images are delayed because they require more time to process. Perhaps the data are incomplete, waiting for perihelion to reveal a fuller picture. Yet to acknowledge this does not erase the significance of the silence. For the silence itself has become part of the narrative, woven as tightly into the comet's journey as its orbit or its coma. And so, the question is not only what 3I Atlas is, but also what our reaction to it reveals. Do we accept patience as part of science, or do we demand immediacy, even when the cosmos resists? Do we see restraint as professionalism, or as secrecy? These choices belong as much to us as to the agencies we look toward for guidance. In the end, silence is not neutral. It shapes belief, nurtures suspicion, and transforms a comet into a mirror of our own restlessness. That is why the theories matter not for their accuracy, but for what they tell us about the fragile bond between knowledge, trust, and imagination. And so, having lingered in the realm of speculation, we now turn to the institutions themselves, the governments and space agencies that decide what to share, when to share it, and how to frame the story of the sky. Behind every telescope, every observatory, every image of the cosmos that reaches our screens, there is an institution making choices. Governments fund the instruments, agencies allocate the observation time, committees decide what to release and when. The story of 3I Atlas is therefore not only about astronomy, it is also about control, about the delicate balance between science as an open pursuit and science as a managed resource. Space has never been entirely free of politics. The Cold War taught us that. Satellites, telescopes, even planetary probes carried as much symbolic weight as scientific value. To capture the first image, to announce the first discovery, was not just a triumph of knowledge but a statement of national power. That legacy lingers. Each new interstellar visitor is not merely a curiosity, it is an opportunity to shape narratives, to stand at the podium of cosmic discovery. And narratives, as governments know well, can be managed. Consider how images are filtered. Hubble and Webb do not upload raw snapshots directly to the public. Data arrive as streams of numbers, wavelengths, photon counts, calibration values that must be processed, colorized, and framed for release. This is not deception, it is necessity. But in that necessity lies discretion. Agencies decide which datasets to highlight, which wavelengths to emphasize, which images to polish for public eyes. In most cases, the process is transparent, even celebrated. Yet when an object as unusual as 3I Atlas appears, the very same process can look suspicious. There is also the matter of classification. Some astronomical data, especially from spacecraft that straddle the line between civilian and military, pass through review boards before they are cleared. Satellites that observe near-Earth space can reveal more than comets. They can expose the movement of defense assets. Even interstellar wanderers, by coincidence, may be caught in fields of view that brush against sensitive regions of the sky. It is not impossible that part of the silence around Atlas reflects this hidden machinery of clearance and review. And then there is distraction. Media attention is finite, and governments know how to steer it. When coverage of one celestial event swells uncomfortably large, another story can be amplified to draw eyes away. Some observers have noticed how neatly the spotlight shifted toward other comets, brightening, fragmenting, more photogenic in their behavior, while Atlas drifted through its strange quiet. Coincidence, perhaps. But once suspicion takes root, even coincidence begins to look like orchestration. What makes this situation delicate is that the boundary between necessary caution and deliberate control is hard to see from the outside. Scientists may insist that the delay is technical, the public, however, perceives management. Between those two perceptions lies a widening gap, a space where doubt, once seeded, can grow unchecked. And so, when we ask who controls the story of 3I Atlas, the answer is layered. It is controlled by physics, by scheduling, by the fragile machinery of data processing. But it is also, unavoidably, controlled by institutions with their own priorities, their own rhythms, their own interest in shaping how the cosmos is seen. The story of control becomes sharper when we look at how governments have historically framed the unknown. When the Pentagon began releasing information on UAP's unidentified aerial phenomena, the documents were meticulously cautious. They admitted anomalies but refused interpretation, acknowledging strangeness while withholding meaning. The result was paradoxical: transparency that did not feel transparent, openness that still carried the taste of secrecy. Something similar may be unfolding now with 3I Atlas. By offering just enough information to prevent outrage, but not enough to satisfy curiosity, agencies walk the same thin line. Control also extends to the timing of announcements. A discovery framed at the right moment can dominate headlines, serving as a reminder of national prestige or scientific leadership. A discovery framed poorly can create confusion, or worse, panic. For a comet from beyond the stars, green, enormous, and unrepeatable, the stakes are higher. Governments and space agencies may feel that releasing images too quickly, before every pixel is interpreted, could risk fueling headlines about alien visitors or engineered objects. From their perspective, silence buys safety. From the outside, silence breeds suspicion. We should not forget the role of funding. Space science, as noble as it seems, is bound to budgets and politics. A high-profile interstellar visitor could be used as leverage for new missions, or as justification for expanding programs. Controlling the story means controlling the flow of resources. If the narrative leans toward mystery and significance, politicians may be more inclined to invest. If the narrative becomes mired in conspiracy, that same funding could wither. In this way, every release about Atlas is not only scientific but also strategic. There is also the question of collaboration or competition. Observatories across the world, from Europe to Asia to private institutions, all vie for a piece of the interstellar prize. Who gets credit for which discovery? Who publishes first? Who is remembered in the history books? In that race, the silence of one agency may not be only about data integrity but about positioning. Waiting to release could mean ensuring that the final interpretation and the prestige that comes with it carries their seal. For the public, none of this is visible. All we feel is the absence of images, the pause in updates, the sense of being held at arm's length from something rare and wondrous. Yet behind the curtain, the calculus of control may be relentless. It does not necessarily mean deception or conspiracy. Often, it is simply the machinery of institutions, cautious and strategic, moving at their own pace. Still, when those movements intersect with an object as singular as 3I Atlas, they change the story in ways no telescope ever could. In the end, the question of control is not about one comet, one telescope, or even one agency. It is about the larger story of how humanity mediates its relationship with the cosmos. Space is vast, indifferent, and open to anyone with eyes to see it. Yet the gateways through which most of us experience it, press conferences, image releases, curated social media posts, are narrow. They are shaped by committees, filtered through priorities, and sometimes restrained by politics. This does not mean that scientists themselves are complicit in deception. Most astronomers are eager to share, their careers built on collaboration and open data. But they operate within systems larger than themselves, systems where national interest, institutional caution, and the need for narrative control all converge. A comet, like 3I Atlas, arriving from beyond the stars, touches not only the boundaries of science but also the boundaries of trust. It is here that we feel the tension most keenly. For the public, silence looks like secrecy. For the agencies, silence feels like prudence. Between those two perceptions lies a widening gap, and it is in that gap that rumours take root, that theories multiply, and that the fragile bond between observers and the observed begins to fray. 3i Atlas reminds us that the sky is never just science. It is also story-crafted, contested, and controlled. And when control becomes too visible, the wonder can feel distant, even diminished. And so, having traced the role of institutions in shaping what we see and what we don't, we turn next to memory, to the history of the interstellar visitors before Atlas. For this is not the first time we have faced a wanderer from beyond, and in their stories lie the comparisons that make this silence stand out. Before 3i Atlas drifted into our awareness, there was another wanderer that forced us to confront the idea of interstellar visitors. In October 2017, Pan-STARRS, a sky survey telescope in Hawaii, detected a faint object racing through the solar system on a hyperbolic path. It was quickly named ʻOumuamua, a Hawaiian word meaning a scout or a messenger from afar arriving first. Unlike any asteroid or comet we had catalogued, it left us with more questions than answers, but it also showed us how openness in science could soften mystery rather than sharpen it. From the beginning, ʻOumuamua's case was marked by transparency. Observatories around the world turned their instruments toward it, and data poured in. Its shape was inferred from its flickering light curve, elongated like a cigar, or perhaps flat and pancake-like, tumbling chaotically as it sped along. Its trajectory showed a slight acceleration that could not be explained solely by gravity, and yet, instead of silence, there was a chorus of discussion. Papers appeared within months. Debates unfolded in public. Scientists speculated openly about whether the acceleration came from comet-like outgassing or from some unknown mechanism. Images of ʻOumuamua itself were faint, little more than streaks of light against the stars, but those images were shared widely. They were accompanied by artist illustrations, graphs of brightness variation, and simulations of tumbling motion. Together, these fragments created a vivid sense of the object for the public. Even as its nature remained uncertain, no one felt excluded from the process of discovery. The mystery was not hidden, it was shared. That openness helped shape the way ʻOumuamua is remembered. Yes, it was strange, but it was strange in plain sight. Every scientist, every student, every curious person with an internet connection could see the same puzzle unfold. The lack of a definitive answer became part of the fascination, not a source of mistrust. The transparency itself became a form of reassurance. The cosmos still held surprises, but we were confronting them together. This stands in contrast to 3i Atlas. Where ʻOumuamua's data were laid bare almost immediately, Atlas seems wrapped in pauses and delays. Where ʻOumuamua became a global conversation, Atlas feels like a whisper behind closed doors. That difference is why so many look back to 2017, not only to remember the first interstellar messenger, but to measure how the story of such visitors is being told today. In ʻOumuamua's case, the image history is not about glossy photographs, but about visibility, about being allowed to watch the scientific process unfold in real time. That visibility turned uncertainty into wonder instead of suspicion, and it is precisely that memory that makes the hush around 3i Atlas feel so stark. ʻOumuamua also became a case study in how swiftly science can adapt when the world is watching. Within weeks of its discovery, international teams coordinated observations across multiple telescopes, optical, infrared, and radio. The European Southern Observatory's Very Large Telescope tracked its brightness. The Green Bank Telescope listened for possible radio emissions, if only to rule out exotic explanations. Data flowed into preprints, journals, and conferences, where scientists debated openly. The pace was unusual, almost breathless, but it reflected the rarity of the opportunity. Everyone knew the object would fade quickly as it sped away, and there would be no second chance. The openness did not mean agreement. Some argued that outgassing from hidden ices explained the strange acceleration, even if no coma or tail was visible. Others contended that its shape, so extreme compared to known asteroids, hinted at something more exotic. A few, most famously Avi Loeb, raised the possibility that Oumuamua could be artificial, a fragment of alien technology like a discarded solar sail. These ideas were controversial, even fringe, but they were not suppressed. They were published, discussed, challenged, and rebutted in the open. The public saw not a polished conclusion, but the living process of science, uncertain, argumentative, messy, and real. Even the absence of clear images became part of the conversation. Oumuamua was too small and too faint to yield the kind of dramatic photographs people expected. What they saw instead were streaks and graphs, abstractions translated into colourful illustrations. Yet those illustrations were shared freely, not as proof but as visual metaphors. The effect was subtle but important. It reminded people that astronomy is not only about pictures. Sometimes it is about the faintest whisper of light, the curve of a graph, the hum of data. By revealing this, scientists drew the public closer, rather than pushing them away. The transparency also created a kind of collective ownership. Oumuamua did not belong to any single agency or nation. It belonged to the world's imagination. When the International Astronomical Union announced its name, it resonated globally, a poetic gesture that framed the object not as an anomaly but as a visitor. The openness of its image history made that metaphor believable. People could feel part of the encounter, even if they had never looked through a telescope. This is what makes the memory of Oumuamua so instructive. The science was uncertain, but the communication was open. The mystery was unresolved, but it was shared. By contrast with three-eye atlas, we see how silence can shift the tone. Uncertainty begins to feel like secrecy, and wonder begins to shade into suspicion. The lesson is not just about comets. It is about how stories are told, and how trust is built or broken in the spaces between discovery and disclosure. In hindsight, Oumuamua left us with no definitive answer, only possibilities. Was it a shard of rock ejected from a distant star system? A fragment of cometary ice that shed invisible gases? Or, as some speculated, a fragment of alien technology, a messenger built rather than born? None of these ideas achieved consensus. But what mattered most was that the debate was visible. The absence of certainty did not corrode trust, because the process was open for all to see. The public could watch astronomers argue, weigh evidence, propose models, and discard them. They could see how science works in real time, not as a voice of authority delivering pronouncements, but as a chorus of minds exploring the unknown together. In that shared uncertainty lay a kind of reassurance. It showed that the cosmos was not being filtered through secrecy, but through human curiosity, with all its flaws and brilliance exposed. This openness gave Oumuamua a lasting place in cultural memory. Even years later, the name evokes mystery, tinged with wonder rather than mistrust. It became a symbol not of silence but of dialogue, and it set a benchmark. This is what transparency can look like when humanity confronts a messenger from beyond. Which is why, when Three-Eye Atlas arrived, the difference was felt so sharply. Where Oumuamua's story was told in the open, Atlas seems wrapped in pauses and hesitation. Where Oumuamua left us with debates, Atlas leaves us with gaps. And in those gaps, the questions have grown louder than the comet's glow. And so, having looked back to Oumuamua and the openness that framed it, we turn next to Borisov, the second interstellar visitor, and one whose behaviour was far more familiar. For in comparing the ordinary with the extraordinary, we begin to see why Three-Eye Atlas stands apart. If Oumuamua was a riddle wrapped in uncertainty, Borisov was a story told in plain sight. In late 2019, an amateur astronomer in Crimea, Gennady Borisov, discovered a faint, moving object that quickly revealed itself as the second confirmed interstellar visitor. Unlike its predecessor, Borisov carried none of the ambiguity that sparked debates about alien sails or artificial origins. Its behaviour was so recognisably comet-like that astronomers could study it almost as if it belonged here, and crucially, its image history was open, abundant, and steady. From the beginning, Borisov displayed the hallmarks of an active comet: a bright coma of gas and dust, a visible tail streaming away from the sun, and a spectrum rich with familiar molecules. Telescopes across the world observed it in detail. Hubble captured crisp photographs of its diffuse body, and the European Southern Observatory's instruments traced its chemistry with remarkable clarity. Even the Atacama Large Millimeter, divided by Submillimeter Array, ALMA, joined the effort, mapping molecules in its outflow. Each new observation was quickly shared, and within months, a rich archive of images and spectra was available to the public. This openness mattered. For scientists, it meant abundant data to compare with comets born in our own solar system. For the public, it meant that the strange idea of an interstellar comet felt tangible rather than abstract. They could see Borisov with their own eyes, in photographs released almost as soon as they were processed. The transparency turned an extraordinary event into a shared experience, woven into the collective memory of skywatchers around the globe. What Borisov revealed was continuity. Its composition, water, ice, carbon monoxide, cyanogen, was much like comets catalogued here at home. Its behaviour, though on a hyperbolic path, echoed the scripts astronomers knew by heart. It may have been born around another star, but it was not alien in the sense of incomprehensible. Rather, it was familiar, comforting, almost ordinary. And in its ordinariness, it demonstrated how interstellar wanderers can be studied without secrecy, without silence, without the shadows that now surround 3i Atlas. Borisov's case also highlighted how swiftly international collaboration can mobilize. Researchers from multiple continents coordinated schedules, pooled data, and compared findings in real time. Preprints circulated, press conferences announced results, and media outlets eagerly shared the newest photographs. The comet's passage was not only a scientific event, but also a media event, and it left no space for theories of concealment or delay. Transparency itself became part of Borisov's legacy. In hindsight, Borisov was the open book of interstellar visitors, strange by virtue of its origin, but ordinary in its nature. It showed us what openness looks like when science and the public move together, and it is that memory, the memory of clarity, that sharpens the contrast with the hush around 3i Atlas today. What made Borisov such a reassuring visitor was not only its transparency, but its familiarity. For once, an interstellar object behaved exactly as astronomers expected. Its coma expanded predictably as it neared the Sunday. Its tail brightened and lengthened in rhythm with its approach. The light it reflected followed patterns already charted by decades of cometary study. Where ʻOumuamua had provoked confusion, Borisov inspired recognition. It was, in a sense, the first interstellar visitor that felt like an old friend. Scientists seized the opportunity. The Hubble Space Telescope captured some of the clearest images of its activity, revealing a body just a few kilometers across, but enveloped in a bright shroud of dust and gas. ALMA detected carbon monoxide at levels far higher than typical solar system comets, suggesting that Borisov had formed in a much colder environment than our Sun's neighbourhood. Instead of fueling mystery, this finding deepened understanding. It hinted that planetary systems beyond our own could generate comets rich in volatiles, preserving ices that vanish more readily here. The steady stream of information created a narrative of trust. Amateur astronomers shared their own images, stacking exposures night after night, and found that their results matched the professional data. In classrooms and planetariums, teachers could show students real-time pictures of an interstellar comet, confident that they were seeing the same thing as the experts. For once, the boundary between public wonder and professional science nearly disappeared. This was transparency at its most powerful, not only open data, but a sense of inclusion. People felt that they were part of the discovery, walking alongside the scientists rather than being led by them. Every new image was like a page in a shared diary, documenting a moment the world might never see again. In this way, Borisov became more than an astronomical event. It was a cultural one. The comet was covered in newspapers, featured in documentaries, and discussed across online communities. And because the flow of information was constant, the story never risked collapsing into suspicion or silence. Borisov was strange only in its origin, not in its telling. It is against this backdrop that the story of Three-Eye Atlas grows uneasy. Where Borisov reassured us with openness and clarity, Atlas confronts us with pauses and gaps. The memory of Borisov's transparency becomes a kind of measuring stick, and against it, the silence of today feels even louder. Looking back, the legacy of Borisov is clarity. Its interstellar status made it rare, but its cometary behavior made it comprehensible. Every observation added to a picture that felt solid, almost comforting. A traveller from another star, yes, but one that played by rules we already understood. The transparency of its image, history steady, open, abundant, meant that the mystery of its origin did not spill over into mistrust. This is the contrast that lingers today. With Borisov, science spoke loudly and often, and the world listened. With Three-Eye Atlas, the same institutions seem muted, their voices subdued at the very moment when curiosity is greatest. Where Borisov's openness fostered wonder, Atlas's silence invites doubt. The difference is not just in the comets, but in the way their stories are told. And so, as we close this chapter on Borisov, we turn our eyes back to Atlas itself. For in order to understand why it unsettles us, we must trace the features that make it unlike its predecessors, the peculiar coma, the green glow, the defiant anti-tail. It is here, in the break from the familiar, that Atlas begins to stand apart. If Borisov reassured us by behaving like a comet from home, Three-Eye Atlas unsettles us by doing the opposite. From its earliest observations, it seemed determined to bend the rules, to resist the tidy categories that astronomers had built over centuries. To study Atlas is to be reminded that the universe still resists easy explanation. Start with its coma. Most comets display atmospheres of gas and dust that grow steadily as they warm, usually dominated by water vapor sublimating from ice. Atlas, however, seems driven primarily by carbon dioxide. Its coma swelled to hundreds of thousands of kilometers across, dwarfing Earth in scale long before water vapor should have taken over as the main driver. Webb spectroscopy hinted at exotic chemistry, carbon monoxide, OCS, and crystalline water ice, yet carbon dioxide remained the loudest signature. A comet powered by such chemistry feels like an emissary from a colder, stranger nursery than anything in our own system. Then there is the matter of colour. Many comets glow faintly green when C2 molecules fluoresce under sunlight, but Atlas seemed unusually vivid, its hue deep enough to catch the eyes of amateur astronomers with modest instruments. To casual sky watchers, the comet looked alive with a kind of unearthly fire. Science could explain it, yes, but the intensity invited speculation, feeding the sense that something extraordinary was unfolding. The geometry of its tail added another layer of strangeness. Alongside the normal stream of dust pointing away from the sun, Atlas displayed an anti-tail, a streak that appeared to defy expectation by pointing sunward. Astronomers understood the effect as a trick of perspective. Dust particles spread along the orbital path, lit from Earth's viewpoint, but the optics mattered less than the impression. To the public, an inverted tail seemed like a challenge to the very laws of nature. To storytellers, it became a symbol of inversion, of a visitor that would not obey the script. Brightness was the final surprise. Models predicted a steady rise in magnitude, but Atlas brightened more quickly than anticipated. Its glow leapt ahead of the curve, as though hidden reservoirs of volatile material were being tapped. Amateur reports in August and September suggested that its light doubled faster than models allowed. The effect was mesmerizing but disconcerting, like watching a flame burn hotter than its fuel should permit. What else might lie hidden within this fragment from beyond? Taken together, these features painted a portrait of difference. Unlike Borisov, which fit neatly into our categories, Atlas refused to conform. It was comet-like, but not a comet as we knew them. It was familiar enough to study, but strange enough to resist full understanding. This duality, half known, half unknown, is what broke the pattern, what made silence around it so glaring. For when an object both fits and does not fit, the absence of explanation is amplified. The silence becomes heavier than the facts themselves. And so, as Atlas grew stranger with each observation, the story of its differences began to take on a gravity of its own. It was not just another visitor. It was a reminder that the universe still contains rules we do not yet recognize. To grasp how profoundly 3i Atlas unsettles the established script, we need only look at how astronomers categorize comets. Traditionally, a comet's behavior is a balance of ice and dust. Water vapor drives activity close to the sun, while carbon monoxide and carbon dioxide play supporting roles at greater distances. In Atlas, that balance is inverted. Carbon dioxide dominates the show, powering an immense halo long before water could take over. For scientists, this suggests a birthplace colder and more volatile rich than the outer reaches of our Oort cloud, perhaps deep within the frozen wastes around another star. For the public, it suggests an alienness that no amount of scientific reassurance can quite soften. The scale itself borders on the absurd. Reports estimated its coma expanding beyond 300,000 kilometers across, with some measurements pushing even higher. This is not just large, it is planetary in scale. To imagine a body, only a few kilometers wide, cloaked in an atmosphere vast enough to envelop Earth is to confront an image that defies intuition. Comets in our system can grow impressive comi, yes, but Atlas seemed to cross an unseen threshold. Its proportions were outsized, as though it carried with it a different set of cosmic instructions. Then came the anti-tail, a feature both scientifically understood and narratively irresistible. Astronomers quickly explained it as geometry tiny dust grains arrayed along the orbital path, creating the illusion of a tail pointing sunward, but explanations did little to diminish the impression. To many, the inverted tail became a symbol of reversal, of something refusing to behave as expected. Photographs of the phenomenon circulated widely, with captions that emphasized its defiance. The science was clear, but the story was louder. A comet from another star, flaunting a tail that bent the rules. Even its brightness seemed to argue against convention. Atlas did not simply glow, it surged. Observers tracked its magnitude rising faster than models predicted, as though reserves of volatile material were venting more explosively than expected. Each surge in light became another moment where expectations frayed. Was this normal for an interstellar traveler, or was Atlas revealing a new kind of behavior altogether? The lack of definitive answers only deepened the sense of strangeness. All of this adds weight to the silence that surrounds it. A familiar comet, even if spectacular, could weather a pause in updates without much notice. But a comet like Atlas, bursting with anomalies, demands narrative. When that narrative falters, when updates fail to appear, the vacuum amplifies the oddities. Suddenly the green coma, the inverted tail, the surging brightness are not just data points, they are mysteries magnified by absence. This is how Atlas breaks the pattern. It is not only unusual in itself, it is unusual in context. Its behavior deviates from the familiar script, and the silence of institutions makes those deviations feel larger still. What should be an astrophysical puzzle becomes a cultural riddle, a comet transformed into a mirror of our unease. By now, the picture of 3i Atlas is clear in its contradictions. It is comet-like, yet comet-defiant. It glows with familiar chemistry, yet in proportions that overturn expectations. It wears a coma vast enough to humble planets, yet clings to a fragile nucleus only kilometers wide. Its tail points both with and against the sun, as though reminding us that perspective itself can deceive. And through it all, its brightness rises faster than models allow, a light outpacing our equations. These are not trivial quirks. Each anomaly chips at the framework that makes comets legible to us. We categorize to create comfort, to make the strange comprehensible. But Atlas resists neat placement. It belongs both within the canon of comets and outside it. It is kin, yet stranger. And because of that duality, every silence around it feels amplified, as though the institutions themselves are hesitating at the threshold of what they can say with confidence. For astronomers, this tension is exhilarating. A puzzle that resists resolution is a chance to expand models, to refine theories, to learn something genuinely new. But for the public, the same tension reads differently. To them, Atlas is not just another point of data, it is a rupture in the expected script. And when the rupture is met with quiet, imagination fills the gap. What science sees as complexity, the world can perceive as secrecy. This is how Atlas truly breaks the pattern, not only by its chemistry, its tail, its brightness, but by the way it collides with our expectations of how cosmic stories are told. ʻOumuamua was mysterious but shared. Borisov was familiar and open. Atlas is strange and hushed, a visitor whose tale feels incomplete. The silence that surrounds it becomes part of the anomaly, another layer of difference. And so, having mapped the strangeness of Atlas and how it departs from the familiar paths of its predecessors, we now turn to the way attention itself has been steered. For in the same months that Atlas grew brighter, other comets rose suddenly into the spotlight, and some have wondered whether those stories were meant to distract us from this one. Every sky is full of stories, but not all stories are told with equal volume. In the weeks when 3i Atlas should have commanded attention, its coma swelling, its tail inverting, its brightness racing ahead, other comets stepped into the spotlight. Names like Lemon and Swan began circulating in headlines, their photogenic arcs filling news feeds, their fragments caught in dazzling photographs. It was as if, while one actor delivered the most unusual performance, the stage lights tilted elsewhere. To some, this was simply coincidence. The heavens are generous. Comets come and go with seasonal rhythm. If Atlas was strange, Swan was dramatic, Lemon was bright, and each earned its share of notice. But in the mind already attuned to silence, coincidence begins to resemble choreography. The sudden burst of attention for lesser comets seemed, to some, like sleight of hand. A magician waving brightly coloured scarves while something subtler is hidden in the other palm. It is not difficult to see why this idea appeals. Our world is saturated with algorithms and agendas, with the invisible currents of media shaping what we notice and what we overlook. If social networks can amplify the trivial and bury the essential, why not the cosmos as well? A comet fragmenting into shards is a ready-made spectacle, easier to digest than the subtler mysteries of a green glow and an anti-tail. The eye is drawn to fireworks, the ear is drawn to loudness. Atlas, in its quiet strangeness, was left in shadow. Yet distraction, deliberate or not, is powerful. Attention is a finite resource, and where it flows, significance follows. By amplifying other comets, the sense of urgency around Atlas dulled. Its anomalies, instead of becoming nightly headlines, remained the quiet talk of astronomy circles and amateur observers. The public gaze, so brief and so easily diverted, was pointed elsewhere. Perhaps this was only the natural ebb and flow of fascination, or perhaps, as some whisper, it was guided a decision to foreground the spectacular and background the unsettling. In either case, the effect was the same. Atlas's peculiarities slipped from the spotlight, and in their place came brighter, simpler tales. The strangeness was not explained, it was eclipsed. This is the essence of the distraction theory. Not that Atlas was erased, but that it was outshone. In a theatre of infinite stars, attention itself becomes a form of control, deciding which mysteries thrive in the public mind and which fade into silence. And in that theatre, the silence can matter as much as the comet's light. To see how distraction works, one must look not only at the comets themselves, but at the way their stories are told. Swan, for example, was a comet that fragmented spectacularly. Its images, brilliant shards drifting apart like embers from a fire, circulated widely, splashed across astronomy magazines, featured in nightly news segments. Lemon, with its more modest glow, nonetheless became a darling of astrophotographers, its golden arc appearing in countless feeds. Both were dramatic in ways that lent themselves to simple narratives: birth, brightness, breakup. 3I Atlas, by contrast, offered no such tidy arc. Its anomalies and anti-tail, a chemistry of excess carbon dioxide, a brightness outpacing prediction, did not translate easily into pictures that spoke for themselves. They required explanation, context, nuance. And nuance rarely trends. A fragmented comet is a visual headline. A green glow of uncertain chemistry is a footnote waiting to be misunderstood. This imbalance may be natural, but it is also useful. Media thrives on spectacle, and institutions sometimes lean into that fact. A fragmenting comet can be celebrated without risk, shared without controversy. It is safe, self-contained, and easily digested by a public hungry for celestial beauty. Atlas, however, carried questions without easy answers. Its silence, when paired with its strangeness, risked spiraling into speculation, and speculation, once unleashed, can be difficult to manage. Thus, the distraction theory suggests a subtle choreography. Let the public gaze drift toward comets that behave like comets, and away from one that refuses to conform. This does not require malice. It requires only the recognition that attention can be guided by what is most photogenic, most palatable, most controllable. In that sense, the distraction is less a conspiracy than a convenience, a redirection that avoids the discomfort of the unexplained. But for those who watch closely, the timing remains unsettling. That Atlas's oddities unfolded just as other comets bloomed into headlines feels too neat, too coincidental, as though the sky itself conspired to provide cover, or as though human hands nudged the spotlight from one performer to another. Whether this is truth or projection hardly matters. The effect is the same. Atlas receded from view, not because it was less strange, but because its strangeness was harder to tell. And so the distraction theory lingers, not because it is proven, but because it feels plausible in a world where attention is currency. We know our feeds can be shaped, our curiosity guided, our gaze redirected. Why should the night sky be any different? In the end, whether the distraction was deliberate or accidental, the result is the same. 3I Atlas slipped from the center of the stage. Other comets dazzled with fireworks, while Atlas lingered in the wings, stranger but quieter, awaiting an audience that never fully gathered. Its anomalies did not vanish. They were simply eclipsed by brighter tails. This raises a larger point about the way wonder is mediated. In the digital age, attention flows not only to what is most important, but to what is easiest to frame, simplest to show, most likely to inspire a click. Spectacle triumphs over subtlety. A comet splitting into fragments is a ready-made drama. A green coma driven by exotic chemistry is not. In this hierarchy of fascination, Atlas was destined to be overlooked unless, of course, one chose to look past the distractions. And here lies the paradox. To the careful observer, the very act of distraction becomes suspicious. If the world is gazing at Swan and Lemon, what is it missing in Atlas? If the news cycle celebrates fragments, what truths remain in the silence? Attention itself begins to feel like misdirection, and absence becomes a kind of evidence. Theories sprout not from what is seen, but from what is left unseen. Thus, the distraction theory is less about proof than about perception. It thrives in the same soil as silence, the gaps, the pauses, the absences where imagination takes root. It may not matter whether anyone orchestrated the diversion. What matters is that people felt diverted, and that feeling reshapes the way Atlas is remembered. And so, From the question of distraction, we turn to a more unsettling possibility. What if the silence is not just about attention or timing or narrative control? What if the institutions know something they cannot say, something so disruptive that secrecy feels safer than truth? Here, the story begins to echo not just astronomy, but allegory. There is a story we tell ourselves about science, that its purpose is always to illuminate, to reveal, to share. But what if, faced with something profoundly disruptive, the instinct was not to show but to shield? This is the unsettling possibility raised by what some call the "don't look up" scenario, borrowing its name from the 2021 film where authorities hide the truth of a looming comet to preserve order. It is a cinematic metaphor, yes, but one that lingers uncomfortably in the silence around 3I Atlas. The comet, after all, is no ordinary wanderer. Its coma is outsized, its chemistry unorthodox, its trajectory uncanny in its convenience. And while most astronomers interpret these anomalies within natural frameworks, a sliver of the public sees in them the outline of something else, something engineered, something not wholly natural. In the absence of continuous data, such interpretations are not easily dismissed. What if, some whisper, Atlas is not a comet at all, but a fragment of alien technology? What if its peculiar glow or its anti-tail is the visible trace of design? It is here that the "don't look up" metaphor gains traction, for in that film, silence was not an accident, but a policy, a deliberate decision to keep disruptive knowledge out of the public's hands. Imagine, for a moment, that agencies observing Atlas detected something they could not explain, a structure, a pattern, a behavior inconsistent with natural origins. What would they do? Announce it immediately, risking panic, misinterpretation, and a flood of conspiracy? Or pause, analyze, and perhaps delay indefinitely, reasoning that the world was not ready for such a revelation? History gives us reason to entertain the question. Governments have withheld astronomical data before, not about comets, but about satellites, observations, and anomalies at the fringes of classified domains. The rationale is always the same: stability first, knowledge second. If that logic applies to earthly skies, why not to interstellar visitors? Of course, the scientific explanation is more likely: exotic chemistry, odd geometry, volatile-driven brightness. These can all be natural, even if unusual. But what matters here is not probability, but perception. To those outside the loop, silence feels indistinguishable from concealment. The longer it stretches, the more it invites the thought that perhaps something has been seen, and perhaps it is being hidden. In that sense, the "don't look up" scenario is not so much a theory about Atlas as it is a mirror held to our trust. It reflects our doubts about whether institutions would truly tell us everything, especially if everything carried consequences too vast to manage. And in that reflection, the comet becomes less a celestial body and more a symbol, a stand-in for the question of how much truth the world is ever allowed to hold at once. The unsettling power of the "don't look up" scenario is that it forces us to imagine not only what might be hidden, but why. Secrecy is never neutral. It always serves a purpose. In the film, officials suppressed knowledge of an extinction-level event to protect economic interests and avoid social collapse. In reality, if something extraordinary was seen in 3I Atlas, the motivations for silence might be more subtle but no less consequential. One possibility is the preservation of stability. History shows how fragile the social order can be when certainty is shaken. Even ambiguous signals like the famous "wow" radio burst of 1977 have fueled waves of speculation that never fully subsided. If images from Atlas contained something that even hinted at artificiality, governments might fear that releasing them would spark panic, destabilize markets, or inflame religious and cultural debates. Better, in such a view, to wait until the evidence is overwhelming or until the story can be carefully managed. Another motivation could be security. If Atlas displayed traits suggestive of technology, say reflective surfaces or emissions inconsistent with natural chemistry, authorities might view it not as a curiosity but as a potential threat. Even if the threat was simply misunderstanding, the instinct of military and political institutions would be to classify first, explain later. Secrecy, in this sense, is not about aliens, but about control of interpretation, control of narrative, control of who gets to look and when. There is also the question of uncertainty itself. Science thrives on ambiguity, but public communication does not. A comet whose features strain existing models may be exciting for researchers, but for the wider world, ambiguity often feels like contradiction. Institutions may fear that openly sharing anomalies without definitive answers risks undermining their authority. Silence becomes a shield against embarrassment, a way of avoiding the appearance of confusion. Yet in protecting their credibility, they may erode it further, for silence speaks in tones louder than doubt. It is important to say again, the most likely explanations for Atlas's strangeness remain natural. Its peculiar chemistry, its anti-tail, its surges of brightness all fit within the broad canvas of what comets can do, even if unusually. But the plausibility of natural explanations does not cancel the perception of secrecy. In fact, it sharpens the irony. The less there is to hide, the more harmful the silence becomes. And so the don't look up scenario endures, not as a proven claim, but as a cultural parable. It embodies our fear that truth can be withheld, that wonder can be managed, that the sky itself might be edited before it reaches our eyes. Whether or not Atlas contains anything alien, the idea that we might not be told is enough to make the silence feel heavier than the comet itself. In the end, the don't look up scenario is less about 3i Atlas itself than about us, our relationship to authority, to trust, and to the unknown. The comet is real, measurable, and strange, but the silence that surrounds it transforms it into something larger, a stage upon which we project our doubts about whether truth can ever be unfiltered. It is unlikely that Atlas hides an engine or a message, unlikely that the green glow is anything more than exotic chemistry, yet the very act of imagining otherwise reveals something important. It shows that silence does not merely conceal, it invites stories, amplifies anxieties, and reminds us that information is never just data. It is also power. To control what is said and what is not is to control how the cosmos is understood. This is why the metaphor resonates so strongly. The film Don't Look Up was satire, but its premise lingers because it exposes a fragile question. Would those in power tell us everything, if everything was too much to bear? With Atlas, that question hovers in the background, unanswerable, but no less real for being speculative. The comet becomes not only a visitor from the stars, but a mirror, reflecting the tension between openness and secrecy in our own world. And so, having explored the cultural unease of this scenario, we turn next to something more practical, the question of missions. What spacecraft, if any, could have been retasked to glimpse Atlas more closely? Could we, in fact, have looked instead of waiting in silence? The answers lie not in allegory, but in the limitations of the machines already in flight. Whenever a rare visitor sweeps through the solar system, a natural question arises. Could we send a spacecraft to meet it? With 3i Atlas, that question surfaced almost immediately. The comet's trajectory carried it past Mars in October and toward perihelion at the end of the month, close enough to tempt the imagination, yet too swift for any new mission to be designed and launched in time. The only hope lay in retasking a spacecraft already in flight. Among the candidates, NASA's Juno orbiter around Jupiter briefly captured the public's imagination. Juno had, after all, delivered breathtaking close-ups of Jupiter's storms and magnetic fields, while also carrying instruments capable of detecting dust and faint emissions. Could it, some wondered, pivot away from its giant host and intercept Atlas? The idea was tantalizing but impractical. Juno's orbit is tightly bound to Jupiter, its maneuvers calculated years in advance to balance science with survival. The delta V extra velocity required to redirect it toward an interstellar comet was far beyond its fuel reserves. Even if trajectory were possible, the timing was not. By the time Juno could have changed course, Atlas would have already passed beyond reach. The spacecraft was built for a different dance, and it could not abandon its partner mid-step. Still, the fact that the question was asked speaks volumes. It reflects the hunger for immediacy, the desire not only to watch Atlas from afar, but to meet it, to grasp it directly with instruments rather than eyes. In an age where planetary flybys and asteroid rendezvous have become routine, the idea of just sending something feels intuitive, yet reality resists. Missions are not improvisations, they are orchestrations of years, even decades. The Juno speculation also revealed the gap between capability and priority. Humanity possesses spacecraft with cameras, spectrometers, and detectors scattered across the solar system, some orbiting Mars, others trailing behind Earth, still others grazing the Sunday. Each might, in theory, catch a glimpse of Atlas, but in practice, observation depends on geometry, scheduling, and the will of institutions. Without clear directives, even the most capable probes can remain silent witnesses, their instruments turned elsewhere. Thus, Juno became a symbol not of what could be done, but of what was not attempted. A reminder that even in a universe filled with machines of vision, we remain bound by choices, budgets, and bureaucracies. The comet passed within cosmic touching distance, and we stayed at the window, watching from afar. If Juno symbolized the impossibility of improvisation, other spacecraft offered reminders of missed potential. Mars, for example, is encircled by orbiters bristling with cameras and spectrometers. NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, India's Mangalyaan, before it fell silent. In early October, as 3I Atlas brushed past the red planet, those spacecraft were in the perfect neighborhood to glimpse it. Yet no images surfaced in the public domain. If they were captured, they were not released. And if they were not attempted, the silence felt doubly poignant. An interstellar comet had passed by our robotic outpost, and we had let it slip. Closer to the Sun, the Parker Solar Probe was racing through its fiery loops, measuring plasma and magnetic fields at the solar frontier. With the right orientation, Parker might have caught Atlas during perihelion, glimpsing its coma as it flared under solar heat. Yet Parker's mission profile is narrowly tailored. Its instruments are tuned to the Sun, not to faint comets darting nearby. To adjust its gaze would mean risking hard-won precision. The same is true of ESA's solar orbiter. These probes were close enough to witness something extraordinary, but not flexible enough to pivot. The reality is sobering. We are surrounded by eyes, but they are not always free to look. Every spacecraft is a compromise, its instruments calibrated, its flight path optimized, its mission scripted years before launch. To ask one to chase a comet like Atlas is to ask a violinist to play a drum solo, possible only at the cost of breaking the instrument. And so, while the technology exists in fragments across the fleet, the orchestra could not shift its music in time. This limitation is not only technical but institutional. Retasking spacecraft requires coordination, approval, and justification. Resources must be balanced, risks weighed, scientific returns debated. Against these realities, the window of Atlas's visit was brief, a matter of weeks. Bureaucracies move more slowly, and so the comet slipped past, unmeasured by machines that might have told its story, if only they had been asked. For the public, this feels like blindness by choice. We see a visitor from the stars sweeping close, and we wonder why our robotic emissaries do not lift their heads. To astronomers, the answer is plain. Missions are not designed for spontaneity, but to the wider world it feels like inattention, even negligence. Thus the silence deepens, not because no one was watching, but because no one could agree to turn the cameras in time. In the end, Juno could not turn, the Mars orbiters did not speak, and the solar probes stayed locked on their primary targets. 3i Atlas passed through the inner system like a guest, glimpsed only through frosted glass, visible but never fully seen. The machinery of exploration was close at hand, but not close enough in flexibility or in will. This is the paradox of our age. We live in a solar system laced with instruments, a flotilla of machines circling planets, trailing Earth, diving into the Sunday. Yet when a wanderer from another star arrives, we find ourselves strangely helpless. Our tools are abundant but inflexible, our gaze precise but narrow. The cosmos delivers surprises on its own timetable, while our institutions prefer calendars measured in years. For some, this gap feels like negligence. For others, it is simply reality. Exploration cannot always improvise. Missions must be safeguarded, objectives preserved. But whichever view one takes, the effect is the same. 3i Atlas became the comet we could not catch, not for lack of desire, but for lack of readiness. And that unreadiness now echoes in the silence, amplifying the sense that something has been missed. Thus, Juno stands as a metaphor, not of blindness in the literal sense, but of a blind spot in our system of exploration. We are ready for what we plan, but not for what arrives unannounced. The universe, however, specializes in the unannounced. And so, as Atlas slipped past without a spacecraft's gaze to capture it, attention turned back to Earth's vantage, and to the one rendezvous that could not be avoided. For in early October, the comet swept near Mars, within reach of instruments circling another world. If Juno was the eye that could not turn, Mars became the mirror that might yet reveal the truth. On the 3rd of October, 2025, 3i Atlas brushed past Mars. It was not a close pass in planetary terms. Millions of kilometers still separated the comet and the planet, but in cosmic terms, it was intimate, a fleeting alignment that placed our interstellar visitor in the sights of a small fleet of machines orbiting the red planet. For a brief window, Mars became the perfect outpost, a cosmic balcony from which to watch the traveller sweep by. This encounter mattered because it offered what Earth could not: geometry. From the surface of our world, Atlas was sliding closer to the sun's glare, its glow increasingly drowned by daylight. Telescopes on the ground strained to see it at all. But from Mars, the angle was better, the view clearer, the opportunity sharper. Instruments aboard NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and the UAE's Hope spacecraft all had, in theory, a chance to capture images or spectra. It was a moment when the story might shift from speculation back to certainty. For astronomers, the Mars flyby was a test. Would the agencies allow their orbiters to look outward, even briefly, instead of downward at the Martian surface? Would the silence break, replaced by fresh images of Atlas from a new vantage point? The questions were not only scientific but symbolic. A picture from Mars orbit would prove that we had not entirely missed our chance, that even if Juno and Parker solar probes stayed blind, our machines at another world had met the comet's gaze. Expectations ran high among skywatchers. Amateur forums buzzed with anticipation, some calculating the viewing geometry, others speculating about what an orbiter might see. Would Atlas's massive coma engulf the frame? Would the green glow appear in crisp detail? Would the anti-tail stretch into the distance, a luminous spear against the Martian sky? In the quiet, imaginations ran unchecked. And then, nothing. Days passed, then weeks. No images were released. No press conferences announced the results. The silence stretched on. For some, this was the familiar rhythm of science. Data gathered, processed, reviewed, and only later released. For others, it was confirmation of suspicion that something had been seen, but withheld. In either case, the effect was the same. The moment of truth had come and gone, and the truth itself remained out of reach. This is the paradox of the Mars flyby. It was at once the most promising opportunity and the most frustrating silence. The comet had passed near another planet, and our machines had been watching. Whether they saw or not, whether they recorded or not, we were left uncertain. Atlas moved on, the questions trailing it like dust. The silence after the Mars flyby became its own kind of spectacle. For weeks, amateur astronomers posted their grainy observations from Earth, chasing the comet as it slid lower into twilight skies. They spoke of changes in brightness, hints of structure in its coma, the faint suggestion of an anti-tail visible even in modest telescopes. These backyard glimpses, though limited, carried the conversation forward in the absence of official word. They reminded the world that Atlas was still there, still brightening, still behaving strangely. Meanwhile, speculation swirled about what the orbiters might have seen. Mars Reconnaissance Orbiter, with its powerful high-rise camera, had stunned the world with detailed images of Martian dunes and avalanches. Could it not have pointed its gaze outward, just once, to catch the interstellar visitor? Mars Express, with its instruments tuned for planetary science, still had cameras capable of wide-field views. Even the UAE's HOPE mission, newer to the scene, could in principle have captured something. The silence from all of them was conspicuous. Explanations were offered. Some suggested that the spacecraft were too busy with scheduled science. Others argued that their instruments were poorly suited for faint-moving targets. A few noted that observation geometry is not trivial. Capturing a comet while orbiting another planet requires precise timing, orientation, and risk. All of this may well be true. Yet, to a watching public, these reasons felt like excuses. After all, when faced with a once-in-a-lifetime encounter, who would not at least try? The disappointment was amplified by memory. In 2014, when Comet Siding Spring brushed past Mars, the orbiters had captured extraordinary data. Images of the comet's coma, even detections of its dust interacting with Mars's atmosphere. If it had been possible then, why not now? The comparison stung. Atlas was rarer, stranger, more significant than Siding Spring, and yet the record remained blank. Thus, the Mars flyby became more than a scientific opportunity missed. It became a parable of perception, that even when the tools are in place, silence can persist. The public imagined vivid images pouring back from Mars, framing Atlas against the red planet's horizon. Instead, they received nothing but conjecture. It was as though the moment of truth had been deliberately muffled, leaving behind not clarity but a deeper unease. As the weeks passed and no official imagery emerged, the Mars flyby began to acquire the weight of myth. People spoke of what might have been seen, inventing pictures in the absence of actual ones. Some imagined a sprawling emerald halo dwarfing Mars itself, captured in a ghostly silhouette. Others speculated about strange flickers within the coma, lights mistaken for signals, features too unsettling to release. These were dreams more than reports, but in the quiet, dreams found fertile ground. The irony is sharp. A moment that should have anchored the narrative in clarity instead deepened the mystery. By rights, the Mars flyby ought to have been the turning point, the point at which doubt gave way to evidence. The orbiters were there, the geometry was favourable, the opportunity unrepeatable. But without images, the flyby became another absence, another hollow in the record of Atlas. For many, that hollow speaks louder than data ever could. Perhaps the orbiters did look, and the images are still being processed, destined for release months or even years later. Perhaps they never turned their cameras at all, their priorities too rigid to permit improvisation. Both explanations are plausible, both are unsatisfying. The silence stretches between them, and the public, left to guess, leans toward the darker interpretation. Silence, once again, becomes indistinguishable from secrecy. What is undeniable is the opportunity lost. No spacecraft will ever again see 3i Atlas from Mars's vantage. Its trajectory is hyperbolic, its visit a singular passage. Like a traveller glimpsed in a crowd, it brushed past, never to return. To miss such a moment is to miss not just data but history, a chance to anchor memory in images instead of speculation. And so the Mars flyby stands as a lesson written in absence. Even surrounded by machines we can still fail to see. Even with vantage points across the solar system, we can still feel blind. For the public, this failure becomes part of Atlas's identity, another reason the comet feels cloaked in silence. And so, from this missed encounter, our attention shifts forward to the final act of the comet's passage, its turn around the Sunday. At perihelion, late in October, Atlas would be tested by fire flaring, fragmenting, or fading as it swept closest to the star that defines our system. There, too, silence and uncertainty would play their part. Every comet carries a moment of trial, a point at which its journey bends toward the sun and heat strips away its disguise. For 3I Atlas, that moment was perihelion, October 29th and 30th, when it would pass nearest to the solar furnace. It was here, in the crucible of sunlight, that the mysteries surrounding Atlas might have revealed themselves or vanished altogether in a shroud of fire. Perihelion is where comets often rewrite their own stories. Some flare brilliantly, venting reserves of volatile ice in spectacular plumes. Others fracture, breaking into shards that scatter like sparks from a log. A few disintegrate entirely, leaving behind only dust, a memory in orbit, a ghost of brightness. With Atlas, all outcomes seemed possible. Its vast coma hinted at deep reservoirs of gas and ice. Its rapid brightening suggested instability, and its anomalous anti-tail implied unusual dynamics at play. The sun would decide which story it would tell. For astronomers, perihelion was both an opportunity and a frustration. The geometry of the event meant that Atlas slipped close to the sun's glare as seen from Earth. Ground-based telescopes struggled, their optics drowned in daylight. Even space telescopes faced challenges. Hubble and Webb cannot point too near the sun without risking their instruments. The best hopes rested with spacecraft built for solar study Parker Solar Probe, solar orbiter machines, designed to withstand the glare, but not optimized for faint comets. This alignment created an irony almost poetic. Just as Atlas reached its most dramatic point, it also became hardest to observe. Its trial by sunlight unfolded behind a curtain, tantalizing but obscured. For scientists, this meant uncertainty. For the public, it meant another silence, another moment when the comet seemed to slip into secrecy at the very instant when answers should have come. Speculation rushed to fill the gap. Would Atlas shatter like Ison in 2013, disintegrating into nothing as it skimmed the solar inferno? Would it erupt in brilliance, its green glow swelling into a beacon visible even in twilight skies? Or would it pass quietly, defying both doom and spectacle, continuing its hyperbolic escape unchanged? Each possibility carried weight. Each became a story told in advance. But without images, without data, they remained stories only. Thus, perihelion became less an event witnessed than an event imagined, a hinge in the comet's journey where truth itself seemed hidden in the glare. For those who had followed Atlas since its discovery, this was both thrilling and frustrating. The knowledge that history was unfolding, but the inability to see it clearly. The difficulty of observing perihelion is as old as cometary science itself. When a comet swings close to the sun, its brilliance is veiled by the very star that fuels it. Ancient astronomers called these apparitions omens, appearing suddenly at dusk or dawn and then vanishing into daylight. Even today, with spacecraft orbiting beyond Earth, the challenge remains. Our best instruments must either look away for safety or peer through filters not designed for the subtleties of a fading green glow. For 3I Atlas, this limitation proved especially cruel. Here was an interstellar wanderer, carrying with it the potential to answer questions no comet of our system could, and yet its most critical chapter unfolded half-hidden. Scientists worked with what they could, modeling its expected brightness curve, predicting fragmentation thresholds, calculating how much gas and dust it might shed as it skimmed closest to the Sunday. But models, no matter how sophisticated, are not witnesses. They cannot replace the image of a coma swelling or the sudden collapse of a nucleus into dust. Whispers of amateur observations trickled in glimpses caught in twilight skies, reports of faint changes in magnitude, suggestions that Atlas might have dimmed or flickered as perihelion passed. None were definitive. Each was a piece of rumour draped in the cloak of uncertainty. For those hungry for clarity, it was like listening for music in static. Meanwhile, expectations collided with memory. In 2013, Comet Ison had promised a comet of the century, only to break apart at perihelion, leaving nothing but a streak of dust. Some feared Atlas would meet the same fate, its grand green veil consumed by the Sunday. Others hoped for survival, imagining a comet that would brighten again as it swung outward, leaving behind a luminous farewell gift to the sky. Both scenarios carried symbolic weight: destruction as reminder of cosmic fragility, survival as proof of resilience from beyond the stars. But in the silence of official updates, these hopes and fears remained suspended. No images arrived to confirm a break or a blaze. The world was left with anticipation without resolution. A cliffhanger stretched across the arc of the comet's path. Perihelion became not just a physical turning point, but a narrative one, a place where the story could not move forward because the record itself was blank. And so, while Atlas may have spoken in gas and dust, in the language of solar heat and cosmic chemistry, what reached us was not its voice but its absence. Perihelion passed, and with it the best chance to see the comet reveal its innermost self. What remained was silence, and the questions that silence carried. In the aftermath of perihelion, reports were contradictory. Some amateur astronomers suggested that 3I Atlas had dimmed abruptly, a sign that its nucleus might have fractured under solar stress. Others noted that its brightness curve seemed steadier than expected, hinting that it had survived intact. Without direct spacecraft images, these claims could not be reconciled. Atlas emerged from the glare, much as it had entered it, uncertain, half-known, a story waiting to be told but never fully spoken. This uncertainty gave perihelion a paradoxical weight. It was both the climax of the comet's journey and the point where the record is thinnest. In scientific terms, perihelion should have been decisive. The heat of the sun strips away ambiguity, revealing what lies within. A comet that survives speaks of strength, of ices locked deep and stable. A comet that shatters tells of fragility, of stresses too great to endure. Either way, perihelion writes a truth. But in the case of Atlas, that truth remained hidden, its handwriting blurred by the light of the Sunday. And so, instead of clarity, we are left with echoes. Did Atlas fracture into shards too small to trace, scattering itself like embers blown from a fire? Or did it blaze through perihelion, transformed but intact, its green coma swelling once more as it fled the furnace? The absence of clear evidence makes both possibilities linger in imagination. In that lingering, the silence itself becomes a narrative, the idea that perhaps the story was seen but never shown. For the public, the missed opportunity stings more deeply because of what perihelion symbolizes. It is the trial by fire, the crucible in which comets reveal their secret architecture. To miss that moment is to miss the closest thing to truth these fragile wanderers ever offer. And when that truth is obscured, speculation becomes inevitable. Atlas, already strange, became stranger still, not just for what it did, but for what we failed to witness. Thus, perihelion joins the list of moments that define Atlas not by what was revealed, but by what was hidden. The silence is now part of its identity, stitched into its legacy as tightly as its orbit. A comet from another star, tested by our sun and yet never fully seen. And so, having traced Atlas through its trial by fire, We turn next to the theories that grow in silence's wake. For in the absence of clear images, even the most outlandish possibilities find room to thrive, and among them is one of the strangest of all, the old conspiracy called Project Blue Beam. When silence lingers too long, it invites not only curiosity but conspiracy. Into the vacuum left by missing images of Three-Eye Atlas, some voices have reached for one of the strangest and most persistent theories of modern folklore, Project Blue Beam. Born in the 1992 from the writings of Canadian journalist Serge Monast, Blue Beam claims that governments and hidden powers intend to stage false celestial events, fabricated visions in the sky, holographic apparitions, even a simulated alien arrival as tools of control. It is a theory dismissed by mainstream science, but like many such tales it thrives not on evidence but on doubt. Applied to Atlas, the idea unfolds with eerie symmetry. Here we have a comet that is real, measurable, undeniable, yet wrapped in silence, its most critical moments obscured. Some conspiracy theorists suggest that the missing data is not absence, but substitution. Perhaps the images withheld by Hubble or JWST show something inconsistent with a natural body, geometric structures, engineered emissions, or behavior too artificial to pass as chance. In this telling, Blue Beam provides the script. The event is hidden, edited, or reframed, while the public receives only a carefully curated version of the truth. Why would anyone do this? The answers vary as wildly as the theory itself. Some claim it is to preserve control, preventing panic if evidence of extraterrestrial technology were glimpsed. Others imagine that Atlas is being folded into a larger narrative, that its silence will be used as prelude to a staged revelation, a manufactured contact, designed to unify or destabilize societies. Still others see it as practice, a rehearsal for a future deception, with the comet serving as a canvas for testing the manipulation of global perception. Most scientists reject these ideas outright, and for good reason. The logistics of faking celestial events are overwhelming. Amateur astronomers around the world point their telescopes skyward every night. To manipulate every independent observer would be impossible. The sky is not a theatre with one spotlight, but a dome seen from millions of angles. A hoax of that scale would unravel almost instantly, yet the point of Blue Beam has never been its plausibility. Its power lies in its ability to fill the silence, to explain the unexplainable by invoking hidden hands. And so, when the silence around Atlas deepened, when Hubble stayed quiet, when Mars orbiters released nothing, when perihelion passed without images, the theory reawakened. Not because it fits the facts, but because it fits the feeling, the sense of being excluded, of watching the stage while suspecting that the real play is happening behind the curtain. In this way, Project Blue Beam became less a theory about Atlas than a reflection of mistrust. It reveals how quickly the absence of transparency can transform a comet into a conspiracy, how silence itself becomes a canvas for projection. Whether true or not, the theory thrives on the same element that defines Atlas's story so far, the gap between what is known and what is shown. The endurance of Project Blue Beam in the public imagination says less about comets than it does about trust. It is, at its core, a story about hidden control, about the possibility that what we see in the sky is not what it appears to be. When silence surrounds an event as unusual as Three-Eye Atlas, the old myth resurfaces almost naturally, like a reflex of suspicion. The absence of images becomes evidence in itself. If nothing is shown, then something must be hidden. What makes the theory so magnetic is its elasticity. It can bend to fit almost any narrative. If Atlas shattered at perihelion and no one showed it, then perhaps it never existed at all. If it grew brighter than expected, the glow could be dismissed as projection. If the data showed anomalies, that too could be attributed to manipulation. Silence, ambiguity, contradiction, these are the very conditions under which Blue Beam thrives, and Atlas has provided all three. Yet, there is an irony here. If governments truly wish to convince the world of staged celestial events, there would be easier and more spectacular ways to do it than with a faint interstellar comet half lost in the sun's glare. A genuine attempt at deception would aim for visibility, not obscurity. And so, while Atlas has been folded into Bluebeam lore, it does not fit the theory's supposed purpose. It is not a holographic performance beamed across the sky, but a real object, observed by amateurs with modest telescopes, its path confirmed by multiple observatories. Still, the resonance remains. For believers, Atlas's silence proves the theory. For skeptics, it proves only the hazards of speculation. Yet both sides agree on one point: transparency matters. Without it, imagination takes the reins. Without it, even the faint glow of a comet becomes raw material for visions of control and manipulation. What this reveals is less about Atlas and more about us. Project Bluebeam thrives because it answers a feeling. The feeling that the world is not as open as it appears, that knowledge is filtered, that the sky itself might be a stage. And as long as that feeling persists, silence will always be fertile soil for conspiracy. In the end, Project Bluebeam is unlikely to explain 3i Atlas. The comet is real, its orbit measured, its chemistry at least partly understood. No hologram can bend starlight. No projection can leave behind a dust trail visible in amateur telescopes across continents. Yet the persistence of the theory reveals a truth of a different kind. When silence endures, the human mind insists on filling it. The less we are told, the more we imagine. Atlas, then, becomes a mirror for our collective unease. On one side is the scientific narrative volatile ices venting, geometries creating anti-tails, brightness curves straining but not breaking our models. On the other is the conspiratorial narrative, where secrecy signals, deception, and every withheld image becomes evidence of control. Both stories are born from the same soil, the hunger to know, and the discomfort of not knowing. Governments and agencies may dismiss Bluebeam as fringe, but they cannot dismiss the mistrust that sustains it. For mistrust grows strongest where transparency is weakest. If Atlas had been documented openly, with images flowing freely, the conspiracy would have withered. Instead, silence nourished it, lending plausibility to what should have been implausible. This is the danger of withholding. It creates the very spectres it hopes to avoid. And so, as Project Bluebeam drifts once more through the conversation, we are left not with proof of manipulation, but with a reminder of perception. To some, Atlas is a comet. To others, it is a cipher, a staged play, a secret withheld. In truth, it is both less and more. Less, because the evidence for deception is absent. More, because the way we respond reveals our own fragility. We fear not just what comets might hide, but what silence might mean. And so, having passed through the realm of conspiracy, we turn now to the reality behind the scenes, how space images are actually made public, why they take time to appear, and what delays are natural rather than nefarious. For to understand the silence, we must first understand the machinery of vision itself. To understand the silence around 3i Atlas, we must first step into the workshop of modern astronomy, the long, meticulous process by which raw starlight becomes a picture fit for public eyes. The gap between telescope and headline is larger than most imagine. What seems to the public like a simple photograph is, in truth, the result of weeks or even months of careful handling. When a telescope such as Hubble or JWST observes a target, the first product is not an image at all, but a stream of data arrays of numbers representing photons captured across wavelengths. These raw files are riddled with noise, streaks from cosmic rays, and distortions from the instruments themselves. Astronomers must clean them, subtracting background artifacts, calibrating brightness levels, and stitching together exposures taken in different filters. Only after this quiet labour does a recognizable picture emerge. Even then, the picture is not ready for public release. Teams must review the data, comparing it to models, ensuring that what is shown is accurate. For comets, the task is especially tricky. Their activity is dynamic, changing from night to night. A sudden outburst can skew brightness. A fragment can masquerade as a background star. Releasing images too quickly risks misleading not only the public but the scientific community itself. This is why embargoes exist. Research groups are often given exclusive access to data for months, even a year, so they can publish peer-reviewed papers before the images are widely shared. It is a safeguard against half-truths, a way of protecting both the science and the scientists. Yet to the outside world, this delay can look like suppression. Silence feels less like patience and more like secrecy. Understanding this process does not dissolve the mystery of Atlas, but it reframes it. What may appear as deliberate concealment could simply be the slow machinery of scientific care. The data may already exist, waiting quietly in archives, invisible to all but a handful of researchers until its turn arrives. And so, before we assume that silence means conspiracy, we must remember the invisible hands that shape every image of the cosmos. What we see is never the sky itself, but the sky after passing through instruments, algorithms, and committees of human judgment. It is the truth, but truth translated. Consider, for example, the way colour is added to astronomical images. When Hubble photographs a galaxy or JWST peers into a nebula, the detectors do not record the cosmos in the familiar hues of human sight. Instead, they capture slices of light infrared, ultraviolet, narrow bands, invisible to our eyes. Astronomers assign these slices to colours after the fact, layering them into composite images that are both scientifically meaningful and visually striking. The process is not deceitful, but interpretive, a translation of wavelengths into a language we can understand. Yet to those unaware of the method, the artistry can seem suspicious, as though the image were manufactured rather than revealed. The same is true of timing. A single published photograph might represent dozens of exposures taken across hours or days. Cosmic rays that strike the detector must be erased. Imperfections in the optics must be corrected. Sometimes, entire datasets are discarded because conditions changed or instruments glitched. To the scientists, this is routine. To the public, the delay between observation and release feels like an empty silence that invites speculation. There are also the layers of bureaucracy. Each space telescope is not only a scientific instrument but an institution. Proposals are reviewed, schedules approved, observations logged, results archived, and only then, often after internal committees weigh the quality of the data or images released. The system is designed for rigour, not for speed. But in an era when citizen astronomers can share telescope captures instantly on social media, the contrast is glaring. A scientist's careful delay looks, from the outside, like a deliberate withholding. 3i Atlas highlights this gap sharply. Amateur observers tracked its brightening, posted grainy but immediate photographs, and shared their excitement online. Meanwhile, professional observatories remained silent, their data tucked behind protocols. The comet's anomalies, its massive coma, its inverted tail, its surging light, were being documented, but the official channels released little. To many, it felt like a blackout. To scientists, it was simply the necessary lag between raw data and responsible analysis. This is the paradox of modern astronomy. The more careful the process, the more secretive it appears. Transparency is not as simple as immediacy. It is bound to the slow rhythm of peer review, institutional caution, and the ethics of accuracy. Yet in the gap between what is known and what is shared, imagination blooms unchecked. Silence, however well-intentioned, feeds suspicion. Ultimately, the silence around 3i Atlas may be less a conspiracy than a collision of expectations. On one side stands the public, accustomed to instant imagery, smartphones streaming live, amateur telescopes posting nightly updates, a digital culture where delay itself feels suspicious. On the other side stand the institutions of astronomy, bound to caution, peer review, and protocols that measure progress in months, not hours. Between them lies a gulf that Atlas has illuminated more starkly than most. It is worth remembering that much of the data probably already exists. Images of Atlas may be sitting in archives at this very moment, still raw, awaiting calibration and interpretation. Spectra may be logged, waiting to be cross-checked against models. These records are not hidden in the sense of being concealed, they are hidden in the sense of being unfinished, like a manuscript locked in an editor's desk. They will, eventually, emerge, but the comet itself will by then be gone, and the world will have moved on. This is the bittersweet reality of cosmic reporting. By the time official images are shared, they are no longer breaking news but historical documents. The wonder they convey is real, but the urgency has evaporated. For a visitor like Atlas, whose presence is brief and unrepeatable, this lag feels particularly painful. The silence during its passage amplified its mystery, and the release afterward, if it comes, will feel like an echo of a song already faded. Yet understanding the process also restores a measure of perspective. What looks like secrecy may simply be rigor. What feels like delay may be respect for truth, for accuracy, for the integrity of science itself. The silence is not proof of deception, but proof of care, though care expressed in a way that does not always align with the rhythms of public expectation. And so, having traced the machinery of image-making and the reasons behind the hush, we turn next to the sky itself once more. For whether released or withheld, images alone cannot tell the full story. The comet is still out there, its light still measurable, its anomalies still waiting to be interpreted. The question now is, what should we look for in the next images, and how can we tell if what we see is ordinary or extraordinary? With all the silence and delay, one question rises above the rest. When the next images of 3i Atlas finally appear, whether from Hubble archives, solar probes, or the hands of amateur astronomers, what should we look for? The comet has already revealed itself as a creature of anomalies. Its green glow, its anti-tail, its massive halo of carbon dioxide have unsettled expectations. The task now is to sift the coming images for signs that confirm, complicate, or overturn what we think we know. The first thing to watch is the coma itself. Comae are fragile atmospheres, expanding and contracting in response to solar heating. For Atlas, the sheer scale of its coma was one of the earliest surprises, stretching hundreds of thousands of kilometers across. New images could reveal whether that scale persisted after perihelion, whether the green tint deepened or faded, and whether any subtle structures, shells, jets, or striations hint at a nucleus under stress. A shrinking or lopsided coma might betray fragmentation already in progress. Next comes the tail, the anti-tail phenomenon dust aligned along the comet's orbital plane so that it appears to point sunward remains one of Atlas's most striking features. Fresh images may show whether that illusion continues, or whether the geometry shifts as it moves farther from the sunday. If multiple tails appear one of dust, another of ionized gas, it could clarify the balance of forces driving its activity. Such details matter because they tell us not only about Atlas's present behavior, but about its birthplace, its chemistry, and its resilience. Brightness is another key. Cometary light curves follow patterns shaped by distance from the sun and the availability of volatile ices. Atlas defied those patterns once already, brightening too quickly for comfort. If new images show it dimming more sharply than expected, it may confirm that it fractured or exhausted its reserves. If it steadies or brightens again, it may indicate a deeper well of material evidence that this interstellar visitor carries secrets of an environment colder and richer than our own system's edge. Finally, the most tantalizing evidence may come not from images, but from spectra data that reveal what elements and molecules are present in the coma. Already, carbon dioxide has played an outsized role. Future observations might confirm unusual abundances, perhaps revealing ices rarely seen in local comets. Any chemical oddity could point back to the comet's home system, a fingerprint of a star long since left behind. These are the threads to watch: coma, tail, brightness, chemistry. Each new image will be a fragment of an unfolding story, each dataset a clue. And while no single frame will answer the riddles of Atlas, together they can sketch the outline of a truth hiding in plain sight. Beyond the broad strokes of coma, tail, and brightness, there are subtler signs worth watching, details that often escape casual notice, but whisper loudly to those who know how to listen. Jets, for instance, narrow streams of gas and dust that erupt from fractures on the nucleus. In high-resolution images, jets appear as faint, fan-like features cutting across the glow of the coma. Their direction and intensity can reveal the shape of the nucleus, the placement of active regions, even the way the comet spins. If Atlas shows multiple jets, crossing like filaments of light, it may indicate a restless surface under constant stress. Fragmentation is another crucial marker. A healthy comet nucleus remains hidden, its core invisible beneath the surrounding haze. But if the nucleus breaks apart, shards may peek through tiny knots of brightness, moving alongside the main body. In some comets, these fragments become mini-comets of their own, each trailing dust. Detecting such fragments in Atlas would be decisive. It would mean that the interstellar traveler did not survive perihelion intact, and that what we are seeing now is a family of debris rather than a single visitor. Then there are structures within the tail itself. Dust tails are shaped not only by sunlight but by the pressure of the solar wind, a stream of charged particles. Subtle ripples, kinks, or bends can betray fluctuations in that wind. Ion tails glowing in ultraviolet or blue often behave differently: straighter, thinner, more reactive to magnetic fields. If Atlas shows both, their interplay could teach us about the sun's influence on matter that formed under a different star. Spectroscopy deepens the puzzle further. Already, Atlas has confounded expectations with its dominance of carbon dioxide. Future spectra could sharpen the picture, identifying trace molecules: methane, ethane, ammonia, perhaps even exotic ices, unseen in local comets. Each detection would carry implications about the comet's birth environment. Did it form in a colder nebula, a system richer in certain volatiles? Was it flung outward during the violent youth of another star, carrying with it the fingerprints of alien chemistry? The answers may lie in spectral lines, etched faintly in its light. Even the rate of fading matters. As Atlas recedes from the sun, its coma should contract, its brightness diminish, its tail grow faint. But if the decline is slower than expected or uneven, punctuated by sudden bursts, it may suggest reservoirs of activity hidden deep within. Such persistence would mark Atlas as more resilient than fragile, a traveller able to endure a furnace and still burn brightly as it drifts back into the dark. In these subtleties lies the real work of interpreting the next images. They are not just pictures for wonder, but data for diagnosis, each nuance a clue about where Atlas came from, what it is made of, and how long it may survive. Yet even with all these markers: coma, jets, tails, spectra, fragments, there is a deeper challenge. How do we separate what belongs to 3i Atlas from what belongs to ourselves? Telescopes are not neutral mirrors, they are extensions of human intention. The way images are processed, the colours chosen, the features emphasised, each decision shapes what we believe we see. Two teams, working from the same data, may present different portraits, one highlighting the subtle green chemistry, another emphasising faint dust structures. Neither is false, but both are partial. This is why skepticism, humility, and cross-checking matter. For the public, this means looking not only at the pictures, but at the provenance of the pictures. Who released them, under what conditions, and with what commentary. Amateur captures, though less precise, provide an important counterweight. They remind us that the sky is shared, that no agency owns the truth of a comet. When citizen astronomers post raw, unprocessed views, they contribute a kind of honesty, imperfect, but immediate, that complements the polished beauty of official releases. In the story of Atlas, both voices are essential. The danger, of course, is overinterpretation. A jet mistaken for a fragment, a cosmic ray mistaken for a flare, a camera artifact mistaken for geometry. Each can spiral into theories unsupported by evidence. Yet the opposite danger is equally real. Dismissing anomalies too quickly, smoothing over strangeness until the story feels tidy. Atlas challenges us to walk the narrow path between wonder and rigor, between imagination and discipline. And perhaps that is the larger lesson. What to look for in the next images is not only scientific signatures, jets, spectra, fragments, but also the practice of seeing itself. We are being asked to learn patience, to hold multiple possibilities in mind, to resist both the lure of easy spectacle and the comfort of premature certainty. In this sense, Atlas is not just an object of study but a teacher, showing us how fragile and fallible our ways of knowing can be. And so, as we prepare for the next glimpse of this visitor, we carry both a checklist and a caution. We know what to seek, and we know how easily silence can distort. The comet may yet surprise us, or it may slip away, leaving its mysteries intact. Either way, the act of watching matters. For even if the data never resolves every anomaly, the very attempt to see clearly is its own form of truth. And so, having laid out what to look for, we approach the final arc of this story. Section 17 will bring us to the closing speculation, not just the science, not just the silence, but the possibilities that linger beyond both. What might we still be missing about 3i Atlas, and what does its passage mean for how we see ourselves beneath the stars? Every story leaves shadows where the light does not fall, and with 3i Atlas those shadows may prove as revealing as the facts themselves. We know the comet exists, we know its orbit is hyperbolic, and we know its chemistry hints at origins beyond our own Sunday. But what do we not know? What remains concealed in the silence, or blurred in the glare, or lost in the lag between data and disclosure? One possibility is that Atlas has already fragmented in ways too subtle to confirm. A nucleus cracking into pieces smaller than a kilometre might still masquerade as a single point of brightness in most images. By the time higher resolution data emerges, the fragments may have drifted too far to reconstruct. In that sense, the comet we think of as singular may already be plural, a family of shards carried outward together. Another possibility lies in its chemistry. The green glow, attributed to carbon dioxide-driven emissions and excited diatomic carbon, could mask rarer volatiles that we have not yet measured. Spectra from perihelion or beyond may reveal molecules unknown in our solar system, clues to environments colder, richer, or more chaotic than anything nearby. If so, Atlas would not just be a comet from another star, but a fragment of an alien nursery, bearing the fingerprints of worlds we will never see. There is also the question of behaviour. Comets follow patterns, but Atlas has strained those patterns at every turn. Its rapid brightening, its inverted tail, its vast coma all point to processes that do not sit comfortably within our models. What if these anomalies are not accidents of timing or geometry, but signs of a fundamentally different composition? What if interstellar comets obey rules we have only begun to glimpse, rules that widen the definition of what a comet can be? And finally, there is the human possibility, that what we are missing is not in the comet, but in ourselves. The silence around Atlas has revealed how fragile trust can be, how easily gaps in communication become breeding grounds for fear, suspicion, and myth. Perhaps the lesson is not only about alien chemistry, but about our own need for openness, for patience, for humility in the face of mystery. In these shadows lies the closing speculation, that Atlas's true gift is not the answers it carries, but the questions it leaves behind. Questions that stretch outward like its tail, pointing beyond the sun into a night sky that will always hold more than we can see. Speculation, by its nature, is both fragile and fertile. It grows where certainty falters, filling the spaces science has not yet illuminated. With 3i Atlas, speculation has flourished because so much remains unfinished. The absence of close-up images, the ambiguity of perihelion, the silence of orbiters that might have looked, but did not speak. In that silence, the imagination stretches outward, weaving possibilities that range from sober to surreal. One thread of speculation suggests that Atlas may not be unique at all. Instead of a solitary traveller, it could be the first of many, a herald of a stream of interstellar debris crossing our path. If so, Atlas might be the beginning of a pattern rather than an isolated event. ʻOumuamua, Borisov, now Atlas 3 in less than a decade, after millennia of none. Perhaps the galaxy is more porous than we believed, its boundaries more fluid, its visitors more frequent. What we might be missing is not simply the details of one comet, but the realization that the solar system is less an island and more a crossroads. Another thread ventures into more unsettling territory, that Atlas might carry information, not in the deliberate sense of alien engineering, but as a natural archive. Dust grains within its coma may contain isotopes, unlike any we have catalogued, fragments of minerals shaped under alien suns, chemical fingerprints of conditions never present in our own nebula. Each particle is a message, but one written in a language of chemistry, waiting for us to learn how to read it. If we fail to study it fully before it vanishes, that message may be lost forever. And there is always the more daring speculation that perhaps some signatures really would hint at technology. Brightness surges too sharp, structures too symmetrical, emissions too precise. Most scientists dismiss such notions, and rightly so. Yet the fact that these ideas persist tells us something about the comet's hold on our imagination. What we might be missing is not evidence of machines in the sky, but the deeper recognition of how badly we want the universe to answer us back. In each of these threads, the comet remains a mirror as much as a mystery. Its silence reflects our impatience. Its anomalies reflect our hunger for significance. What we are missing, perhaps, is the ability to sit with the unknown, to let the question remain unanswered without rushing to fill it with certainty or suspicion. And so, the closing speculation is not only about Atlas itself, but about us, our readiness, our restraint, our relationship to wonder. As 3i Atlas recedes into the outer dark, it leaves us with fewer certainties than we might wish, but perhaps with more meaning than we expected. We know it came from beyond, a shard of distance immeasurable. We know it was fleeting, its visit measured in months against a backdrop of millennia. And we know it resisted neat explanation, straining every category we tried to place it in. What we might be missing is the recognition that this resistance is itself the gift. For a moment, Atlas reminded us that the solar system is not closed, not insulated, not a fortress. It is open to the drift of strangers, to the quiet arrivals of messengers we did not summon. Each one comes uninvited, unannounced, and gone before we can catch our breath. In that sense, Atlas is not a puzzle to be solved, but a reminder to stay awake, to wonder, to accept that the universe will not always tell us everything, but will always show us something. Perhaps the real secret of Atlas is not hidden in its coma or its chemistry, but in its silence. A silence that forces us to confront how much of our trust depends on seeing with our own eyes, and how quickly that trust falters when the view is delayed. A silence that teaches us patience, and also reveals the cost of withholding. A silence that, in its way, speaks louder than disclosure ever could. And so the comet fades, trailing questions instead of conclusions. What was missed? What was hidden? What was never knowable in the first place? These are not failures but invitations, reminders that our place in the cosmos is defined less by mastery than by humility. We are watchers at the edge of a vast stage, catching glimpses of passing players whose names we may never learn. And so, dear traveller, we have followed 3I Atlas from its first faint glimmer in July skies to its fading departure beyond the reach of our instruments. We have traced its anomalies, its silences, its echoes in conspiracy and in science alike. And now, as it drifts outward into the long dark, it leaves us with what every good story leaves, not certainty, but wonder. Perhaps that is all we were ever meant to have. Atlas is not ours to keep, nor to master. It was never a captive of our categories, never a possession of our telescopes. It came as a visitor, carrying questions folded into light, reminding us that the universe is porous, and that we live not on an island but at a crossroads. What passes through may always surprise us, and what departs may always leave us changed. Tonight, as you lay your head down, think of that green glowing traveller slipping silently away, leaving behind no sound, no message, only a trace of brightness in the memory of our skies. Let it be a reminder that even in the vast distances, there are encounters waiting brief, fleeting, beautiful, and enough. Before we part, I'd love to know, where are you listening from this evening? Is it late at night with only the hush of your room around you? Or early morning, with the first light of dawn beginning to creep across your window? Share your time and place if you'd like. It's always comforting to see how our little constellation of listeners stretches across the earth. If this slow journey has brought you even a moment of calm, you're welcome to give the video a like or to subscribe, only if it feels right. That way, this small ship of starlight can keep drifting, carrying new companions into the night. And with that, let us close the book for tonight. May your thoughts be soft, your dreams gentle, and your sleep deep. The stars will still be there when you wake, and perhaps somewhere among them another visitor, already on its way. Good night from the sleepy explorer.